Good morning, everyone. Welcome to the first H2O Product Day. This is our spring release. The new series of events that we are launching to way for us to bring all the latest and greatest innovations that we as a company have been put together over a period of time and showcase it to our customers, users, and community. We're really happy that so many of you are going to be joining in today, and we hope that you'll be excited by all the new innovations that we're bringing to market. We have a full lineup of products, but before we do that, for folks who might be coming in for the first time who know about H2O, I want to sort of introduce ourselves. Right? So H2O AI is an AI-first company. Our mission is to democratize AI for everyone. We've been in business for close to 10 years now, and we built a whole suite of portfolio products to help data scientists, users, developers, data engineers, and businesses adopt and use AI to transform their business completely. But at a high level, our product suite has, we're going to talk about a lot of these products today, but I want to sort of set the stage. We think of the entire AI journey for customers going, adopting AI from scratch all the way to putting them onto production and getting value out of this. And to do that, there's three sort of lines of products. If you think about tools and platforms help you make AI, then the capabilities you need to operate that machine learning and AI models, and then innovate, putting those to change, using those models and your AI to change your business outcomes. And a lot of the products you see, we'll talk about today, will go in this order, starting with our award-winning Auto Product Driverless AI, which a lot of you might be very familiar with, and then our H2O Open Source, which is widely used by over 20,000 organizations globally and hundreds of thousands of data scientists. And we have a lot of new innovative products coming up as well to help you in your make journey. And then we talk about our innovations in things like Document AI, which opens up a new sort of span of use cases to help again address the AI needs for enterprises. And finally, we'll cap it off with our offerings on MLOps, which are helping our customers get their models into production, monitor them, and retrain them as needed and with full value. And all of this is offered as part of our AI Cloud, which is a one platform that brings together all these capabilities for an enterprise. With that, I'm going to hand it over to Michelle Tanko to talk about our AI Cloud offering.
Video. Hi everyone, my name is Michelle Tanko. I'm with H2O on the product team, and today I'm going to be talking to you about our end-to-end product and platform, the H2O AI Cloud. So what we're going to do today is first give a brief overview of what the cloud is for anyone that is new to our end-to-end platform, and then we're going to talk about what's been new and released in the cloud in the last 3 months, and some exciting features that we think you'll be interested to know about that's coming in the next 3 months. So what is the H2O AI Cloud? Well, Vinu just gave you a brief overview, but this is our end-to-end platform that allows different users in the AI journey to build models, to deploy models, understand models, and then build in front-end applications for using these models in production. So you'll hear from many different product teams today, from our AI engines where you build your models to the MLOps teams where we're deploying them. But what I'm going to be focusing about in this first session is more of our platform services and the end-to-end glue and the end-to-end platform that allows you to get into the AI Cloud. The AI Cloud product is available to customers in 2 main ways. The first is the hybrid cloud. So this is for our customers who have strong IT teams, really strong specific details for security, and they want to have their platform in their own environment. This can be in your cloud of choice, so in your own private VPC, AWS, or Azure. It can also be on-prem with anything where Kubernetes will run. For other customers, the managed cloud might be a better solution. So this is ideal when you don't necessarily have an infrastructure or IT team to run your Kubernetes cluster, and you want H2O to handle all of this. So our managed cloud environment, it's the same capabilities as the hybrid cloud. Both of them are feature parity, except for it's all managed by H2O. So it is better for your end users. The admin infrastructure, Kubernetes, and all that is handled by H2O, and you have access to your own private environment for building your own models and using the platform. So what's new in the H2O AI Cloud? These are some of the things that have come out in the last couple months that we wanted to show you. The first is our platform API token. So a lot of end users will interact with our platform from the UI or the front end, but a lot of our data scientists are more likely to be using Python clients in the background. So we have a new easy way to integrate with all of our Python clients and connect securely using a single code, a single platform token. So I'll go ahead and show you right now as a demo on how that works. So I'm going to go to my cloud environment, cloud.h2o.ai, and log in. And after logging in, I'm going to click on my name on the top and go to the CLI and API access page. And this page has all the information that I need to securely access from my local workstation. So I'm going to specifically go to the API section where I can see the different information that I need to run from my local machine, so I can connect to the cloud in my Jupyter notebooks for building models, or maybe in my favorite IDE like PyCharm or VS Code if I'm building an app. So what I'm going to do is go to Jupyter and go ahead and run one of my tutorials. This is Jupyter running on my local machine. And then I'll go to a notebook that is on my local machine for connecting to Driverless AI. So other than importing my libraries, what I do to connect is use the information that I found on my platform page to securely connect to this environment. So I'm going to go ahead and run the connect command, and you'll see that we're using a little bit of security so we don't put our token directly in our notebook, but I have a link that I can click here that will take me to log into the cloud, and it will give me my personalized access token. So I can use this token, and I'm now directly connected to my AI engine manager, and I can go ahead and start connecting to Driverless AI, use AutoML, connect to H2O for building models, and so forth. So this works for all of our APIs, whether you want to build models or you're deploying models with MLOps, or if we start using Feature Store, which we'll talk about today, but you have one token that you can use throughout all of your notebooks and all of your code to start developing from your local machine and securely connecting to your platform. All right, and then the next thing that I want to talk about that's come out recently is specifically for our managed cloud customers at this point, and we're going to talk about H2O Drive. So I'm going to switch environments. The page, thank you, and go to my managed cloud environment. So here I have an instance of the H2O managed cloud that is only for me. It's my internal environment. And again, for each customer, it's a fully dedicated environment. And what I'm going to do here is use the H2O's provided object store to upload data once into the cloud from my favorite location, and then I can access it in Driverless AI or other tools. So here I'll go to the Drive app, and I'll go ahead and open up the application. All right, so here I can see a couple of data sets that I uploaded ahead of time. I can add a new data set. I can connect to my favorite connector, whether it's S3 or Snowflake, or upload files from my local machine. But this is one place to import data, which I can then use throughout the cloud. So if I then go into an instance of Driverless AI, it will show me the data sets that I've uploaded in Drive and allow me to directly use those. With the new profiles, we can use the connectors tab to connect securely to my object store or database of choice. And these credentials are saved securely for me. So every time I want to connect to my S3 bucket, I don't need to put in my access token. By logging into the app, it knows who I am, and I can securely have access to pull in my data. So after we bring these data sets in, we can then either share them with other users by creating a secure link, or we have access to these in other products. All right. Now we're going to talk about what's coming next in the H2O AI Cloud. And the first thing I'm excited to share with you is our new homepage for the AI Cloud platform. So if you're an H2O AI Cloud user, you might be very familiar with the AppStore page, which is our current landing page for the AI Cloud. But we have a new homepage, which our goal is to be able to get all users exactly where they want to go as fast as possible. So this is the first of many versions that we will be sharing with you. And it is available today only internally. This is a sneak preview, so expect this in the next couple of releases within the next quarter. On the homepage, we can easily get into where we can build our own machine learning models. So I can easily get to Driverless AI to spin up an instance of Driverless AI for myself to build models. I can, if I'm interested in doing market basket models, or if I'm interested in doing Hydrogen Torch, which you hear about today. We also have access to applications that help us learn H2O Wave. So we'll talk about Wave later today, but it's a way to start building your own AI applications. And here are some apps that will teach us how to use Wave. In the center, I have access to all the things that I personally am doing. So everyone's center will look a little bit different. Here, I have a lot of apps running. So these are app instances that I want to get to easily. I can go directly into it. So if I want to visit the theme generator app, this application allows me to create custom color themes for Wave, and I can get there from one click of my homepage. So all of my apps are here. My pinned apps are my favorite personal things in the App Store. So what I want to be able to get to and see is available here. And then for any developers, you'll have an imported app section where you can see apps that you've uploaded. So these are applications I own that other people might be using. At the bottom, I have access to common data science workflows. So MLOps for deploying models. I can do text-specific modeling here. Model validation, which you'll hear about later, allows you to understand if your model's ready for production or not, and auto insights for exploring the data. And then finally, we can always see the latest things that have been uploaded in the App Store with the latest uploaded apps, and it tells you what's new. So we have a lot of plans for this page, but we hope this helps everyone get into what they need to do when they're in the AI cloud a little bit faster and improves your user experience. All right. And the last thing I want to announce today before we jump to the next product is I wanted to point out our documentation. So this is available from the docs.h2o AI page, but this is our new H2O AI Cloud documentation, with the goal being to get you to the specific docs that you need. So this overall page gives you a little bit more information about what the cloud is, a quick start tutorial for how to get started, and tells you what the platform is all about and our goals here. You can also see the major capabilities for our cloud, so AI engines for building models. For each of these, you can get into the specific features you might be interested in. So if you are coming to the AI cloud because you want to build a model in Driverless AI, then maybe you should come over to the datasets in Driverless to learn how to import your data. So with access to everything you might need here, more information about MLOps and apps. And if you just want to know more about the cloud in general, this is great. It gives you an idea of our different offerings, how the managed cloud and the hybrid cloud work, who are our target end users, and where do they use different types of functionalities, and so forth. All right. So thanks for your time today. I'm going to pass it off to the next product now. And if you have questions, please feel free to ask them in the chat.
Thank you, Michelle, for wonderful presentation. It's super exciting. I just want to point out that the AI Cloud, we have two main sorts of operations. So we have customers who can use this through our hybrid cloud, and we have customers who are using this through the managed cloud. And this is a new release as well we've done in the last quarter that allows our customers to get advantage of our platforms very quickly. So a lot of our customers are now able to come into a fully managed cloud. This is fully hosted and operated by H2O. And it comes with a highly secure environment that we can have a customer come in, bring in their data safely, launch their apps in the AI engines, including Driverless AI, H2O, and the entire AI cloud. This is, of course, in addition to our hybrid deployment, which is where a lot of our interest customers are. But the managed cloud offers a very, very easy and fast ramp to customers to go to production and get value from AI very quickly. Okay. So that I'm going to hand it over to start the next product, which is Feature Store. We have Thomas Brady here from the Feature Store team to talk about that. I'm going to let it take it forward.
Hi, everyone. This is Thomas Brady.
The screen share didn't work. Let me do it. Hi, everyone. This is Thomas Brady, Product Manager at H2O. Today, I'll be talking about H2O Feature Store. I'll run through a couple of very quick introductory slides, and then we'll pop over to our presentation, or to our. So the biggest thing that we want to start out with in talking about Feature Store, this is a new product that we announced last fall. It's a partnership that we've developed with wireless carrier AT&T. For us, Feature Store is what you should think of as a single source of truth for training data inside the H2O AI Cloud. Go ahead to the next slide. So what problem does Feature Store solve? So today, many customers are building training models, transforming features, making a lot of investment into all the computation and processing for making new features. But a lot of times that's kept within their own system, within databases that are maintained by specific teams. And it's hard for data scientists across an organization to get access to those features. So as a result, you have lost production value that isn't really repurposed for other uses. You have feature data that's siloed within teams. And a lot of times you don't really have a good sense of where your feature data comes from. And it's challenging for you to anticipate drift and any issues that you might have with feature data. So what is H2O Feature Store? H2O Feature Store is the nervous system for an AI organization. With it, you can transform your data into features, maximize that return on investment, and scale model production for your deployment of artificial intelligence. And with Feature Store, you can detect and anticipate drift in your data, detect anomalies, and manage and refresh the lifecycle of your features. And you can also compare feature stores with FeatureRank to get feature recommendations, and with Feature Recommender and offer trade exchange features with Feature Exchange. And the big thing that we also want to underscore is that many folks are moving from on-prem into clouds, and they're creating data clouds. The next level is to move from data clouds to AI clouds. And this is where Feature Store enables this. This shows you sort of an example architecture of the way Feature Store works. So you have raw data coming in or processed features real time and batch. They go through whatever feature engineering pipeline you might desire to use. And then it goes into our Feature Store where there's an online and an offline engine and a metadata registry. And from there, features are consumed downstream for model training, batch predictions, or real-time predictions. And the biggest thing that I want to underscore is that Feature Store is designed with composable architecture. And what I mean by that is that we provide support to any feature engineering pipeline that you might have today, whether it's a driverless AI Mojo, Databricks, Jupyter, Snowflake, or Salesforce Einstein. Those are just a couple of examples. But really, it's designed to traverse clouds and hybrid and on-prem. So think of it as being agnostic to any feature engineering pipeline and able to serve for real-time inference and model training. And with that, I think I'll start sharing my screen and we'll go over to the demo. All right, so I'll quickly go through this demo just to talk about how Feature Store works and give a couple of simple examples of how we envision Feature Store today. So like I said, in this example, we'll use Feature Store data or Feature Store features to train models in driverless AI.
So the problem here is that we want to predict flight delays due to weather disruptions. All the steps that are laid out here before is that we'll register a new project and a new feature set using a Databricks notebook, which I'm showing you right here. And we'll ingest the feature data into the feature store cache and retrieve the raw features in batch and ingest them into Driverless. So we'll only do those portions today. Right now, our data sets that we're using in this example are a historical data set, which we call weather offline, and a simulated real-time flight data, which we have in a CSV file also. In this story, I've laid out a couple of several personas that we'll use. In this case, I'm using superheroes from the Marvel Cinematic Universe. T'Challa is known as Black Panther. He's a data engineer who registers and ingests new features to Feature Store from various data sources. Ororo, who you might also know as Storm, she's a data scientist who consumes features for Feature Store and creates a model logic using Driverless AI. And then Peter Quill, you might know Star-Lord from Guardians of the Galaxy. He's a data engineer who ingests new features to the online Feature Store. And we also have Scott, who will continue throughout the story as we do this type of demo over and over again. He's a data scientist who retrieves data from the online Feature Store and scores it. So we'll start at the very beginning here, where T'Challa, aka Black Panther, sets up and connects to the H2O Feature Store. And once we're connected, what we'll do is we'll input this example data set that's offline weather data, that's historical data. And then we'll also ingest the airline source, which is a large data set that simulates real-time weather airline data coming in. So now that we've ingested all of those, T'Challa is going to go through and register new features. First, he extracts the schema from the two data sets and creates a new project. Then he'll register the schema as the feature set and ingest the feature data. So I'll go through these processes. So I won't go through all of these steps because, especially with the airline data, it's a rather large data set, but I'll skip ahead through all the steps where we register the features. So along each step, what we'll do is we extract the schema. Once that runs, we end up creating a new project that we call Flight Delay Prediction Demo that has this little title called Flight Predictor. I create that new project, and then I register the schema as the feature set inside that project. Once that runs, as you can see, it creates the project name and the feature set name. It has all these attributes related to the feature, who created it, the time that it was created, and what it's used for. After that, we register the weather schema, which is just another set, and create a feature set out of the weather schema. Again, we have all the metadata related to that feature set. And then from there, I go and execute the ingestion step to ingest all the actual feature data into Feature Store. Once that executes, I go back and I join the two feature sets. Here, I'm going to join on the key date so that we can combine them and do transformations from those features. Once we complete that, we do the same exact steps where we extract the schema from the joined feature sets, and then we ingest them into the Feature Store. So first, T'Challa does the same exact step where he registers the airline schema and ingest the joined features. And then from there, we download the airline weather features as a data frame, which we do. And then retrieve them as a Spark frame here. And then moving on, now we're going to go to Ororo. Ororo, as you may know, is Storm from the X-Men. She's going to use the feature set to build the model in Driverless AI. So first, we set a couple simple helper functions that we're using to to pull out the Parquet file and download and extract the Mojo so that we can pull out the features when we run the experiments, and then have connection handling set up to driverless, where I've inputted my driverless URL and the access token. Once I execute those, I connect to driverless, and I retrieve all the features. Great. So from here, I'm going to get the driverless data set. To read cluster. One second, folks. Put these here. Try that retrieval one more time. So while we're waiting on this command to run, going back to the top, what we can talk about with all of the users here, in this scenario, you can imagine that a data engineer has been managing any of the feature engineering pipelines within their organization. And at this point, they've connected to the feature store as a source. They're managing connection handling and setup for the data scientists. And then data scientists come in and they're able to shop. You could think of them browsing through the feature store to find the right features that they want to use for their projects. And what we could do is also go through a quick run through of the UI in feature store, which is probably all right, so I'll give a real quick walkthrough of the UI while we're waiting on those commands to execute. So the first thing you'll see here within the feature store is that there's kind of three main areas. Along the header, you're going to have a very simple dashboard that shows you an overview of your feature store instance, and a search bar where you can conduct advanced search and filter and facet off of whatever dimensions that you want to. On the other left-hand side, you're able to see where projects and feature sets are. And from there, you're able to manage access to projects and manage access to feature sets. Within the project tab, you'll see all the status of projects that are locked or unlocked, and all the waiting access permissions. Within feature sets, you can view all of your feature sets or see all the feature sets that you have access to within the feature store. And you can manage and view all the access requests that are coming your way and grant access to other folks in the feature sets. Within the feature sets, I can open up one feature set here. This is another example of the weather flight delay prediction. And within this feature set, this is called a feature set detail page. On the top side, you have the name of the project it's associated with, the airline schedules, number of features, and who the owner is. Under the key details of the detail page, you'll see the description of it, it was created, version, the feature type, what the data sources were, what the process interval is, and you'll see things related to monitoring, time to live, and these special items where you have sensitive data such as PCI, RPI, SPI, et cetera, within your feature set. And on the right-hand side, you're able to drill down into features and see metadata related to the features. So what's the data type, what's the variable importance, what version of this feature is, and what the reason for the version change was, along with other metadata such as feature statistics. So from here, we'll pop back over to our notebook and check the process here. Okay, it looks like I'm having a little bit of issues here with this data set. It is rather large, as worked before. So maybe what we'll do is we'll pause right here and we'll come back in maybe a little bit if I can get it up and running. With that, I'll turn it back over to the notebook.
Thanks, Thomas. All right, so this is new innovation that we're building over the last sort of few months with our team, and we'll come back and share some of them later. I want to sort of bring up the next product over here real quickly, which is Driverless AI, which is our flagship autonomous product being used many years for a lot of customers. So really exciting to see a lot of innovations happening there. And then we followed up with all the innovations we've done in H2O Wave, which is our open source AI engine, again, widely used by our data scientists all over. So I'll hand it over to Megan Kruka to talk about both Driverless AI and H2O Wave.
Hi, everybody. I'm going to start sharing my screen. Just give me 1 second. Hi, everyone. I'm Megan Kruka. I'm a data scientist at H2O, and today I'm going to be talking a little bit about Driverless AI and H2O 3. They're two of our machine learning products at H2O. I'm going to start with Driverless AI, and we're going to touch on what's new in the recent versions. Driverless AI, as many of you know, is our automated machine learning product. It encompasses best practices from Kaggle grandmasters at our team to really reduce the time to build a model from hopefully months to hours. It's doing a lot of automated machine learning, but it also offers explainability. So while we're incorporating these best practices under the hood, we like to provide reasons around why the model is doing what it's doing, explainability, and fairness. Today, I'm going to be talking about some of the new features that have been added to Driverless AI in the last major release. I'll be focusing a lot today on recipe management. So while Driverless AI is really automated, there is the ability to add recipes to the experiments, and this gives a lot of more customization and control. We've added a recipe management tab to list recipes, add recipes, and most importantly, edit them within the UI. And this kind of leads into our second new feature, transparency. This is, I think, going to be really cool to show, but with each experiment, you'll be able to get Python code that's auto-generated for the final model. And what's great about that is not only can you see everything that's happening in the experiment, but you can actually edit it. And we're going to talk about different reasons why you might want to do that and how to do that today in our demo. The other two features that were recently added that I'll talk about is the admin API. So we've created an admin API for admins so that they can manage entities created by other users. And then finally, we've added Mojo, Shapley support rather, in the C++ Mojo. So the C++ Mojo is offered if you want to deploy in our Python environments. And most recently, we've added Shapley reason codes. If you're familiar with Shapley reason codes, they add a little bit more information to the predictions and how they're being created. So in today's demo, we're going to be talking about if an employee will leave a company. So rather than just getting the probability of an employee leaving, we'll get the reasons behind it. And now that's supported it in the Shapley C++ mojo. Sorry, just C++ mojo rather. Okay, so with that, I'm going to jump into a demo. Right, I'm in Driverless AI right now. And today we're going to be doing a demo of employee attrition. So I can, in Driverless AI, click on the details page and see my data set. Here's my data set rows. I have attrition, the column that I'm going to try to predict, but I also have a bunch of different information about the employee. So we're going to use Driverless AI today to try to predict if we can determine if someone will quit. I'm going to select my target column, which is going to be attrition. And with Driverless AI, that's really it. I'm going to lower some knobs here for the demo purpose, but I don't have to provide much else. Driverless AI is going to, as I mentioned before, encompass all these best practices. So it's going to check for data column type. It's going to check for leakage. Is there drift happening? How should we split the data to check how well it's doing? And then most importantly, it's going to do automated feature engineering, automated algorithm selection, and automatic model tuning. This is all happening under the hood. It just checked my whole data set. It's starting to build models. And we're going to see that pop up here. So here's my models on the left-hand side. The variable importance is in the middle. And some of these variables we're seeing are automatically generated by Driverless AI, like this business travel. This is the target encoding feature. And then I can see how well the model's doing on the right. It's going to keep doing this until it finds the best model. I'm going to switch over to a completed model. This is my same employee data set, but it's already run. And you'll notice the yellow buttons pop up once it's complete. So there'll be things like model interpretation, download that, deployment objects for scoring. You can also tune the experiments. And if you click on this, there's an individual recipe button that I'm going to click on. Okay, and we're going to upload it as a custom recipe. Now what this is that auto-generated Python code. This is going to tell me pretty much exactly what that final model is doing. So now I have a lot more transparency into the model. Most importantly, I can edit this. So I'm going to go down a little bit to talk about two of the functions that I think might be most valuable to our audience. The first is the set model function. So this function is actually showing you all of the parameters of the final algorithm. So I can see the like GVM model that was decided on, and here's all the parameters that were used for the final model. Now, if I was so inclined, I could edit this and do slight modifications to my model. Either I think maybe the performance might be improved, or I want to do it from business purpose. So maybe, for example, I'll increase that regularization a little bit. The other function in this code that's really interesting is the set genes. Now, this is all about the feature engineering. And a lot of times we hear requests like, certain features that are engineered, we don't like. From a business perspective, it might not make sense. Or the other way, I need this column to be in the model. So both of these can be done, and even further customizations in the set genes function. I'm going to go down a little bit. Here I can see all of the features that were built into my model. The beginning of the features are going to be the original ones. So age has an original transformer, nothing was done to it. But I can go ahead and remove that. I don't want this particular feature in, I'm going to delete it. If I go down further, I can see the features that were engineered by Driverless AI automatically. So here I have business travel. We apply target encoding on it. I can modify the parameters of this target encoding. I can remove it completely, or I can force it in. If it's forced, the model will have to use it. So I start to get more control by looking at this particular code and, again, editing it. I can save this as a new recipe and activate it. Driverless AI will automatically check the code to make sure it's okay to use. I'll go back to my experiments tab, and let's try to build another model with this recipe. I'll select my target column again as attrition. The major difference here is I'm going to go to our expert settings, click on recipes, and I'm going to ask to include a specific individual. This is my new recipe, my individual recipe. Save it. And on the left-hand side, you'll see that rather than the typical display here, it's all going to be custom individual. So I've customized this completely. When I launched the experiment, rather than running through all of the methods and steps as before, that feature evolution, the model tuning, it's actually just going to build the final model for me. So I'm going to get a final model with those modifications that I made in the Python code. What's great about that is I'm still going to get the mojo. So I still have that completely independent Java object for deployment. It's training my model now, and once it's done, I'll get that button to get the deployment object, and I can interpret it and all of the things that I normally would do with the driverless AI model. Right? With that, I'm going to go back to my slides and talk a little bit about H2O3. H2O3 is another machine learning product we offer. It is open source, distributed in-memory machine learning. So H2O3, all the algorithms are built by our engineering team, save for XGBoost. They're all built so that they're distributed. What's great about H2O3 is I could import unlimited amounts of data as long as I have a cluster big enough, but I can still connect to the H2O3 cluster using Python or R APIs. So if I really like RStudio, or if I have a PyCharm or Jupyter Notebook set up on my local computer, I can still use that, but connect to the large H2O3 cluster that's running on the cloud or on Hadoop, et cetera. All of the algorithms also support this Mojo, this independent Java deployment object. So I can go ahead and build my model, and then I have this really low latency deployment object that's really flexible and independent. Today we're going to be discussing what's new in H2O3 and also a little bit about how you can use H2O3 in the AI cloud that Michelle was talking about. So I'm going to talk about this and we're going to demo it, but we have a couple of new algorithms that were created. We also have pre and post modeling additions to the platform. And I just want to mention, we have the new ability to import mojos into any H2O3 version. So if you have models created from older versions, you can import those models into newer H2O3 versions for comparison purposes. So this can be really nice when you're thinking about whether or not to use a new model. And then finally, we have explainability. These were all added pretty recently. I'm going to first touch on the algorithms that were added. So one of our new algorithms is called the uplift model. It's a little bit different than a traditional supervised learning model because we're not just trying to predict a target column, but we're trying to predict a target column in relation to some treatments. So going along this example of a lead converting to a customer, I may decide maybe I can get a lead to convert if I offer a discount. So this particular model isn't just figuring out will a lead convert to a customer, but it's figuring out will a lead convert to a customer if they are targeted with a discount. So there's this context of a treatment occurring. And the output of the uplift model is going to be this, this graph on the right. So who's persuadable? Who would actually convert if we offered a discount? Who's a sure thing? They're going to convert to a customer no matter what? Who's never going to? And then finally, who might have an adverse reaction to any marketing? So maybe it will cause them to go the other direction. I'll show a demo of this in a minute. The other algorithm we've had for a while, but we recently added multi-class support for is the Wolfit model. Wolfit model generates rules using decision trees, uses a linear model to filter the rules, and then creates clear text rules that you can use to predict. Show a demo of that too. We've also offered some pre and post modeling, so feature selection with infogram. So this is a new algorithm that's used to determine which features are not admissible. And also a model selection toolbox, which is GLM specific, so linear model specific, but it gives you this idea of what are the best predictors given the constraint that I can't have more than n predictors. And I'll show this too. And then finally, explainability. So we have a lot of global explainability methods available, like variable importance, partial dependence plots, the Shapley summary plot I'm showing on the left hand. We also have local explainability through Shapley reason codes, and this is a graph for a specific row. And what's great about the Shapley reason codes is that it's also available in our Java object. So again, if you want to not only know who's going to quit, but why, that's available in our deployment. All right, so let's go to a demo. I'm going to start by going to our AI cloud that Michelle was showing, and we're going to start by creating an H2O3 cluster. So to do that, I'm going to go to My AI Engines on the top and click on the H2O button on the menu. To launch a new cluster, you can click the blue button, And what's really nice about the AI Engine Manager is that I don't need to know how many nodes a cluster should have or how big the node should be. I can actually just give it information about my data set size, and it's going to tell me. So if I have 10 million rows, 300 columns, how big should this cluster be? And it tells me I should have 2 nodes, each about 50 gigabytes of memory. So this helps a lot. It'll automatically optimize based on your data set size, start the cluster for you. And once I've done that, I'll get this blue hyperlink. I can click on that and see Flow, which is our web-based UI. I can do machine learning by pointing and clicking, or I can connect to this through Python. So I'm gonna go to Jupyter and show this a little through Python and the features. First thing I'm gonna do is I'm gonna import my data. We're gonna use the same data as before, this employee churn data. And I'm going to use the infogram to see which predictors might be helpful, which maybe aren't relevant. So I'm gonna call this infogram model, and we'll see the plot. I can see all my predictors here, and you'll notice that there's this red line. Any features inside that red line we can consider maybe not that helpful. And there are 2 ways we do this. One is total information, which is really, is this variable going to be used by the model? Is it predictive at all for attrition? But the other part of the plot is net information, which is really interesting. Does this feature bring any additional information? Is it unique at all? Right? If there are redundant features, we don't need to use all of them. I can see this information in a table as well. And we see total working years, for example. While it has information regarding attrition, it has no net new information. So if I take a look at a correlation matrix, you can see that total working years is highly correlated with job level, monthly income, age, and years of company. So while it is relevant, maybe with all those other features available, it doesn't bring any new information for the model. So this is a really easy and nice way to figure out how to filter down your features to a strong core set of features. The other feature selection method we've recently added is the model selection toolbox. This is unique to the linear model, but it will automatically figure out the best number of predictors up to 7, as I've said. So you can modify this as you want to, but you'll see a table, and it will give you a list of the features or predictors within this limit, and the highest R-squared value. So again, another easy and quick way to figure out the best features, and this time within the context of a linear model. Going further, let's start by building a model. So we talked about uplift model, which gives us that prediction of a target column within the context of some treatment. So let's say we think we can prevent people from quitting if we say they don't have to travel frequently anymore. So that's going to be our treatment. We're going to build this uplift random forest estimator. It's going to be the same as any other supervised learning model in H2O3, but we're going to add this treatment column. So we're going to try to predict with the context of whether this treatment is applied or not. And the output when you predict is going to be a little bit different. You're going to get this uplift predict. So that is how much would the prediction change if this treatment was applied. The negative values say they're less likely to quit if they didn't have to travel frequently. So not only now are we getting a prediction of churn, but we're also getting a sense of who we could target with maybe this incentive of less travel. We have 10 employees. The other new algorithm that we can show today are rule fit. Rule fit is going to generate a set of rules for me, and I can pull that rules out using the rule importance function. So look at them. I've asked for no more than 5 rules, and the length of the rule can't be more than 5 either. And here's my rules, and I can see them in really clear format. So if the overtime is no, their total working years is greater than 2.5, and they've been at the company less than 30 years, they have a less likelihood of churning. Now that we built some models, let's explain them. So I have my GBM model here. I'm going to build it. H2O offers a lot of out-of-the-box explainability, so I can look at a variable importance plot. I can do partial dependence plots. So let's see. What a partial dependence plot looks like here. You can see, for example, how the prediction changes for different job roles. Are certain job roles more likely to cause churn? But we can also call this explain function, and this is going to run everything automatically. So I'll get this report right away. It'll show me how the model is performing on that data set. What does a variable importance look like? Shapley, partial dependence plots, and so on. So this is really nice if you just want a kind of overview of the model really quickly. And this is a relatively new feature as well. So now that we talked about some of the new features, I'm going to go back to our App Store and talk about what we can do with those models now that we're in this hybrid cloud. Right. The first thing I'm going to do is I have an instance running of AutoDoc, so we're going to go and visit it. AutoDoc is automated documentation of my model. Now this comes out of the box with Driverless AI. I'm sure some of you have seen this download AutoDoc button, but you can also get the AutoDoc within the hybrid cloud through this H2O AutoDoc app. So I can ask to create a new AutoDoc and select it from an H2O free mojo. The output is going to be an automatic documentation with experiment overview. I'll see additional things like feature importance, the final model, how did it do, information about how to reproduce this model, and partial dependence plots. We also offer additional information in the appendix depending on the algorithm. And I can download this in different formats. So that's one of the nice features of using the hybrid cloud with H2O Wave. The other thing I can do is deploy the model. So I've made this model, I have a mojo. I can use the MLOps platform, which we'll talk about more later today, to automatically get a REST API that can be pinged to get predictions in real time. So I can create the deployments. I've already done that using my H2O mojo. And I can click on that, and you'll see a sample curl request that I can ping to get predictions for employee churn. So this is one of a nice feature as well of using the hybrid cloud. Now that I have the mojo, I have a really quick and easy way to deploy the model and manage it. I'm going to jump and talk a couple more slides about what's coming, and then I'll pass it to our next speaker. So what's coming soon in H2O 3? What is GBM improvements? We're adding more robustness to outliers, and we're also adding interaction constraints. Another thing we're adding to GLMs is an influence diagnostic. So how much does one record influence the model coefficients? Do outliers really cause the model to change significantly? For post-modeling, we're adding the ability to import POJOs into newer H2O versions. So if you have older models with a POJO, you can import them into newer H2O versions in the future. And we're adding more mojo support to our new models. Just to touch quickly on our GBM improvements, we are adding a uniform, robust binning. If any of you are building models, you might notice that if you have a skewed column, range-based binning, where I'm binning based on the range of the x-axis, causes a lot of empty bins. So here I have an outlier for income, and when I split by range, I end up with all these empty bins. The uniform robust binning is going to split the non-empty bins in future iterations based on the error. So bins that have a lot of error, we're getting them wrong a lot, we're going to focus on and split. You can think of this kind of like quantile binning, where we're, rather than binning based on range, we're binning based on population of each of the records in each bin. But what's nice about this new binning method is that it, in our tests, have pretty similar performance to quantile binning when you have skewed variables in terms of accuracy, but the time to build is much, much quicker. So we have this really, hopefully similar accuracy to the quantile binning with a significant reduction in time, and that'll be coming out in our next H2O release. And with that, I will pause and hand it over to our next speaker.
Thank you, Megan. That's wonderful. Just to highlight, this is a whole bunch of innovations that we've added to Driverless AI and H2O. So a lot of our existing customers and new customers should be able to take advantage of this, all the new algorithms, especially the customer university that Megan showed earlier. It's a big game changer. It allows a lot of our large enterprise customers, especially with regulated use cases, to be able to get full transparency into our autonomous engine. So you can take an entire model and a pipeline and edit every single part of it, customer needs, and so super excited. This is a big value add for a lot of our existing customers and for the customers. Well, I'm going to hand it over to our next speaker, Dimitri Gordy. He is one of our Kaggle Grand Masters and also a product manager for our Hydrogen Torch and model validation product. He's going to talk about both of those in a bit, but let's start with Hydrogen Torch. Over to you, Dimitri.
Thank you, Vinod. Let me start with sharing the slides. Welcome, everyone. Hydrogen Torch is the product which we launched quite recently, just a few months ago. So I will take a little bit of time to go through the basics about the product. Hydrogen Torch is our deep learning backend. So it's a product which was built from the point of view of providing you with a tool to build deep learning models. And we're focusing on unstructured data as the input. So we're talking about NLP and images. And today we're going to be talking also about audio data. And with Hydrogen Torch, you are enabled to build state-of-the-art deep learning models for unstructured data you have. So we're talking not about just shipping pre-built models and common tasks. So you will be capable of training models to your own data and to your own downstream tasks, including all the state-of-the-art techniques, state-of-the-art architectures, and of course, transfer learning as a part of it. Last but not least, we're also putting a lot of attention on ability to deploy and bring it to production. So, of course, we have it integrated with MLOps, which you will hear about a little bit later, which is our product to serve the models. So, besides Driverless AI and H2O models, it serves as a way to also deploy deep learning Hydrogen Torch models and serve them in production to solve your business needs. What are the key points of Hydrogen Torch I would like to highlight? First of all, we focus on building UI, so a no-code interface for you to start building deep learning models right away. That will require way less headache from your side to code everything in because everything is already built and well tuned and tested for you. And especially for those data scientists who have not that much experience with deep learning overall, this tool can be a quick start to just put the data in and start producing the models which have very, very good performance. And probably equally important also to gain experience about how deep learning works, what are the tricks and what are the important things you can use in deep learning to get the best out of the data you have. So we also see it as a tool for learning and getting more experience, and with more experience being able to build more accurate models with Hydrogen Torch. We have a variety of text, image, and with the upcoming release, audio model problem types to solve with Hydrogen Torch. So we're talking not only about classical classification and regression, but many other tasks included. And this set of the tasks is being constantly extended and, of course, driven by the demand in the market as well. I mentioned the training best practices, which not only includes modern neural network architectures and transfer learning, but it also includes lots of training ideas and training techniques which were developed in the past years, which actually bring the new neural networks to the state-of-the-art level, and sometimes making the best out of the training practice gets you a better result than just building a larger, heavier model or using more complicated neural network architecture. All these parameters also, of course, require some tuning, and we provide the ability to select the best model, to run grid search, to search for the best model accuracy, and pick the most accurate model of all the possible combinations of parameters, neural network architectures, and so on. Last but not least, easy and flexible deployment. As I already mentioned, we're natively deploying Hydrogen Torch models to H2O MLOps, but we also provide the ability to download a package as a Python wheel package of the models you've built and deploy it to your own Python environment if needed. Now let's jump to what's new in Hydrogen Torch. We've made an official launch just a few months ago, but since then we had one minor release and one kind of a larger release coming later this month. They both included quite a lot of changes and improvements. But I would like to mention just a few of those, kind of the major ones. The first one is a new set of object detection algorithms. With this item, I would like just to emphasize that we're enhancing the tools which are already there in Hydrogen Torch by means of trying it out against current competitions and learning on Kaggle about the new techniques which perform better than the rest. And after each competition, we just collect the feedback from the community. We collect our own experience and implement and add new ideas and algorithms into the tool. And that happens with object detection. So we're adding efficient DAT and a few other object detection algorithms. You will be able just to choose out of the list of the algorithms there without the necessity to code and test them. A few other large changes and add-ons listed include instance segmentation problem type. I will show it a little bit detailed in the demo. So this is a new image problem type and an extension of the 12 problem types we had before. We're adding GradCams, which is a way to explain model predictions. And with the GradCams, we're introducing the engine of model explanations in Hydrogen Torch, which will be, of course, expanded and improved over the next releases. We're starting with image data, but of course, we'll expand it to NLP and audio. And last but not least, we're introducing deep learning for audio. Let me just give you a quick overview of these last 3 points. With the instance segmentation, that's a new problem type where we have several objects we would like to detect on the image. And with the instance segmentation, we're not only detecting where exactly on the image they're located, but we're also isolating them one from another and indicating and recognizing each individual object. In this example, we're looking at the cells on an image, and we need to recognize each individual cell, but not only all of them together as a whole. I mentioned the GradCams and an explainability technique we're introducing. Here are the examples of the GradCams applied and captured from the current Hydrogen Torch development. On the left-hand side, we have two sets of the image examples where a model is supposed to classify the images to find planes on them. And GradCams, GradCam is an algorithm to detect the area of an image which drives the prediction done by the model. So with GradCams, with each image, you will be able not only receive the prediction and for some problem times confidence, but also an attempt to explain what is the area on the image that drove the prediction of the model. And in this left-hand side example, we're making sure that the model is trained on recognizing the planes and not background or any other features of images that can mislead or overfit the model. On the right-hand side, we have examples of images of a task called distracted drivers, where the model is expected to predict if a driver is paying attention to the road, or if a driver is having a sip of a coffee, or talking to a passenger. So there are 10 classes of driver behavior. And in this multi-class classification task, we're looking at the grad chems of what model is paying attention to when trying to recognize the attention of the driver. And as expected, we see that model is focusing on where the arm of the driver is, where the driver is looking at, and all the important things we would like the model to focus on for this task. And the last point in my list was deep learning for audio. This is something we're introducing in this version. We're adding audio support for classification and regression tasks. So here you see the screenshot of an example, but let me just switch to a demo to show it to you live. Let me just jump into the classification task and show you an example of a model. Sorry, let me show you the data set first. So we're talking about an example of an audio classification task, where the task is to recognize the birds based on a short recording of an audio from a rainforest. So we have quite a lot of records. Each record is just a 3-second audio. And each recording can contain multiple labels. We have them encoded, but I think we have around 20 different species of birds, which the model is expected to get to recognize from the audio. So in some examples, we have 2 birds, in some 1 bird, and in some we can see more. And I have an experiment which I've already finished running for this audio classification task. And let's look at the prediction insights over here. You see that we have actually pictures, not audios over here. And this is very much intentional because the way we solve this task is we transform the audio into spectrograms, and then we solve it as an image task, which has quite a lot of benefits, because whenever after we convert it to an image, we can use all the modern image neural network architectures, and more importantly, transfer learning from images. And that works very well, even for audio when converted to spectrograms. So here we see a couple of examples of spectrograms of these recordings. We see that this in particular was perfectly predicted. So the true label was 23, and that's the one we predicted. Let's look at some more challenging examples we saw. So let me have a look at this one. So this one had a recording of 2 birds labeled 1 and 10, but the model predicted 1, 3, and 10. So we have a false negative and actually a false positive, sorry. The model predicted 1 and 3, and 10 had very low confidence. So we can use the tools we had in Hydrogen Torch already out of the box with prediction insights, also to investigate the audio data through the spectrogram to see some of the challenging examples and potentially see which types of the recordings, at least visually, cause more challenges to the model. Let me stop here with regards to Hydrogen Torch and take the questions in the chat and pass it to the next presenter.
Thank you, Dimitri. So just I think this is for folks who have not tried Hydrogen Torch before, I definitely highly recommend you to come out to H2O AI and sign up for our free trial and actually try out the Hydrogen Torch product. It brings in a tremendous amount of sophisticated deep learning building tools in a no-code interface. So we made it extremely easy for all our users, irrespective of their expertise with deep learning or with machine learning, to be able to take advantage of the latest and greatest innovations that are happening. This is a product that's built by our Grandmaster team. So I want to highlight that a lot of the innovations and the best practices they sales have been incorporating the product. It's a game changer if you're looking at a lot of these use cases that Dimitri referred to earlier, to be able to use these models. And then but the nice thing about this is all of this is, again, managed completely on the AI Cloud. Once you come to the AI Cloud, your environment is taken care of. Models you produce, they cannot very easily be deployed as well. So super excited about this. I highly recommend everyone try it out. For that, I want to bring up our next presenter. Let's talk about the newest, one of the newer inventions from our side, which is Document AI. This is a product that we launched only this quarter, earlier in January, and we've seen phenomenal traction. This opens up a completely new set of use cases, especially around intelligent document information. We want to introduce Mark Landry, who's also one of our other Kaggle Masters and longtime veteran of H2O, and is running the product and innovation. What's your Mark?
Hello, thanks, Vinod. Let me get my. Sorry about that. My Zoom window is right on top of there. Okay, sorry, yes. So Document AI is a new product that we launched a few months ago. And we have a new self-service UI that sits on top of that now. So for any of you who had kind of followed along in November, December when we launched, we have a nice new interface that's a self-service user interface. So I'll show a little bit of that. At the end, we'll talk a little bit about what Document AI is, because as we've been talking to customers about it over the last few months now, there's a lot of lack of clarity, I suppose, ambiguity of what we really mean with Document AI, and people just meeting us in all different spots where it is. So it's been good for us to learn from speaking with some customers and learning some use cases beyond those we have firsthand experience with, which that's accumulating as well. So the really basic solution space, the vast reservoir of untapped insights, and here you go, electronic documents, document images like faxes, forms, other semi-structured camera phones. We're getting documents in all different ways, and you can think of documents as an image, as the fax, the old school, the new ones are PDFs, but they're just pictures pretty much. And so the untapped part is definitely what we're finding out from customers, is that there's a lot of people that have these documents and they're just sitting around. It could be that your software that you use in your ERP system, or we talk with a lot of manufacturers, it produces documentation and it just sits there, test runs, things like that. And so untapped is that there's data sitting in there that didn't necessarily go into your ERP database, your data lake, whatever you're using. It just kind of sits trapped in those documents. And so some people are using it for validation of their database type, nice tabular data set to make sure that it checks out. The only other option is that it's trapped in a document. And so a validation use case is a very common one that we're seeing. So H2O Document AI is designed to understand those documents, process them, and manage the process of creating these as well. So we'll take a look at that with the self-service UI, with the unstructured text data. Unstructured, semi-structured, it's sitting there, in different forms, but it's not just NLP. We're not just picking up an NLP data set, regular text, and processing it, but we're going to be very similar. And so we'll talk about kind of a hybrid model that what Document AI is underneath. So looking here on the who benefits from this is first of what we've been talking with the last several months with customers. And so this is a wide array of people, business leaders who don't really want to get into the nitty gritty of what we're doing, but they know the documents are out there. They've got to get something done. They're already looking at an incumbent process, perhaps, which is less efficient. And so we're seeing a lot of those kind of replacement sort of things. So operational leaders all the way up to the C-suite, especially the data analytics team. There's data that they know that's trapped there that they may be able to augment a model or something like that. And workflow users especially, this is where you have an incumbent solution. Someone's already sort of reading these documents by hand, typing them up, getting specific information out of it. I haven't really said that yet, but this would be a really common one, is going to be an invoice. And then, if you have multiple vendors, hundreds, thousands of vendors, as a lot of our enterprise customers do, every single invoice is going to be a little different. But the core information is there. We as humans kind of understand it really well. You want the invoice number, you want the purchase order date versus the date it shipped versus the date the bill is due. Those are all different dates. So your basic NER tools will tell you that those are dates. What we're trying to do here is extract specific information that connects with your business processes here. The users of the tool we're building are data scientists and labelers so far. As we talk with customers, we're looking into how we can move that forward. But right now, I'll show you the self-service UI in a few minutes. And that's meant for the data scientists to build models and labelers to help either to create the data sets up front. We were making that as easy as possible and also review them on the back end. So how do we do that? In the middle there, the Document AI self-service UX, again, I'll show you that in a little bit. Intelligent OCR, there's really two big building blocks that happen here. It's more complicated than that. There's more about 4 or 5 that really get involved in a pipeline of handling a document. But the two big building blocks are those next, the second and third bullet point. So an intelligent OCR system, OCR is optical character recognition, but there's multiple ways of doing that. And a lot of people we're talking to are kind of familiar with OCR of maybe 10 years ago, or even current OCR that just isn't really up to the kind of tasks that Dimitri's just showed us are capable out of Hydrogen Torch. You know, convolutional neural nets, fancy, deep learning computer vision algorithms have come a long way, and they do a good job with OCR. But our intelligent OCR is actually, it's a dynamic OCR system too, because many of the customers, maybe half, probably 2/3, have clean PDFs actually, or they have a mix. They might have some clean PDFs that they've come from their own systems, but they also have incoming documents that may be through a fax or just some other kind of picture format. And the difference is, if you've authored a document, the text is just sitting there. You don't actually have to use a computer vision algorithm to read the text. It's just part of that document, copy paste in a PDF. If it's an image, there is no text. And so our system, we built it to have little batches dynamically and figure out what we need and use a state-of-the-art algorithm when we need it, and use also state-of-the-art. It's not even straightforward to just process a PDF. So there's a lot of intelligence that goes into what we're doing in there, so that you don't have to think about it. You don't have to use the right tool for the job. Use ours, which will itself use the right tool for the job. And the second big piece there is the multimodal deep learning. So it's very common to NLP. These documents look like text. We read them like text. So it's the core of it is really handling like a natural language processing problem. But the location of the text is important too. And I'll talk about that when we see some real documents, and you can envision this in your head, that we're not just speaking left to right paragraph form. We don't look at blocks of text. Even something kind of ugly like a Twitter or something is still going to read roughly left to right. When we send documents to each other, we send tables, we send chunks of information that split left and right. Address header is on the top left, things like that. And so the layout of that document is important. That's how we convey information without having to type literally what we mean with about everything on there. So it's a very concise format. We usually send information. And then another key piece of this is the Document AI MLOps. We're working with pipelines that do those two basic building blocks, get the characters out from PDFs or images, and also do classification. But there's multiple classification models people want to run. So you want to take specific parts, like I spoke about with the due date versus the invoice date versus the purchase order date or something like that. If all 3 of those, we might classify them all separately or just get the ones we want. But also we can handle page classification as well. So UCSF, we have a lot of customer videos of kind of the experience we got with them in the summer. Their pipeline does 2 parts. It actually gets a fax that is a medical referral is what they're interested in, but often a medical referral coming in through a referral fax includes all sorts of other information related to that. So it could be just a fax cover sheet, medical notes, clinical notes, things like that, insurance information, various different types of documents. So the first thing we are going to do is classify what each of those pages are in part of that fax. And then specifically, so far, we built a referrals pipeline. We'll extend that to other pipelines too, but the referral document has 115 different things that they want out of that referral. And our AI models have gone, so we do both of those algorithms at the same time. And at the end of the day, the way they score that is a document goes in, JSON comes out through our Document AI MLOps, which is a really simple REST API to use. And I'll show you a little glimpse of what that final output looks like too. So, and what are we actually doing? So the new value and success is, this is something that I guess a lot of customers haven't really thought of too. So we're dealing with, people don't quite think of what piles of data they might have around, or like I said, they have incumbent process. And so the new value, and often be, the next slide I'll talk a little bit about what we're finding is that the robotic process automation, RPA, templates, Kofax, UiPath, these are all kind of in that space of handling documents one by one by one, or one format by format. So if you have a common 10 vendors, you might create a way of doing Document AI without the AI portion, essentially. I'm going to click on this box, and this is where this piece of information comes from. And you can do that, and UCSF had done that to about 100 templates. but they just noticed that even the Pareto principle didn't really apply. They weren't getting an 80-20 out of it. They were more still covering only about 60% or so of all the provider groups that sent them referrals. So they had processed them one by one by one. When we get it from this provider group, this is the way that their form looks. But when it goes outside that form, it had nothing. And so what our tool does is use AI to develop a generalized understanding of what these documents are, so that as the format changes, that's okay. The way it's referred to, the orientation of it, how it appears, all of these change when you don't control the input source is usually what we say. That's where our product thrives, because we're noticing a lot of people are just running into a wall eventually with the template size. So here, some similar things I said. So solutions and ecosystems, like what can you do with those documents? Once you can get the information out, there's several different use cases that people can do, the validation exercises and that's what we had done with PwC a while back. We get a bank confirmation in, extract the information out of that bank confirmation, which is locked in a PDF. It's not an EDI extract, it's not a clean CSV. It comes in differently for every bank, and mirroring that up with what a company says in their general ledger. So in the interest of time, I'm going to flip over, if I can get this working, to the demo. All right, sorry about that. Okay, so here is the Document AI self-service user experience. The user interface is basically laid out on the left side. We have different projects. We've got a lot in here for our testing, but typically you'll run into customers. We had 3 of these at PwC we picked up over time, 3 different documents, 3 different independent sets of information. You can organize these however you like. Continuing through, I've got the medical lab test pulled up here. So document sets is where we'll ingest a data set. I'm not going to show that just in the interest of time, but we can do some deep dives on this. We've done a few material that we'll get out there. Our documentation set, our documentation website is full. You can read and you can walk through some of these examples. Annotation sets are where a lot of this happens. This is what I'm clicked on here. This is how you work with those original documents. And just to show you what I mean, I've got 2 loaded, pretty small, 14, 24 pages. So there's some PDFs in there. Another set that may have come to us later and actually did it when we were doing this, 20 different documents with 90 pages. What do I do with those? I can run the intelligent OCR, and then this attributes column here shows me the different forms that the documents take. So we've got text. I'll show what that looks like. You can really envision what this is going to be, the OCR results. And then label and class are kind of special things to enable us to do the page classification or the entity recognition. And so let me show you a little bit of what these look like. I'll show you originally also how we label. So I'm going to flip into something we call page view. There's really 2 ways of operating. You see a pretty normal kind of user interface here as we walk through some of the information, as our data kind of matures across the pipeline, we build models and so forth. But a big piece of this user experience is mimicking what we spent a lot of time with as we learn this through actual use cases. And these documents are very visual. And so seeing things, labeling things, how we create the data to train the model tends to be a visual process. We need to show the models where the information came from, not just the text. And we have both. So we can see, so here, this user experience, we can see the documents. We can move between documents. Like I said, we don't control the input source in this. We might get medical lab tests from all sorts of different vendors. And the actual format shifts around, but you can see, even just not being experienced with this, that the basic shape is very similar. They're going to refer to it. The column headers are different, but the content similar. We see some some marks through here. These are, different. We can handle all sorts of different document types. And again, we thrive when the input source changes. And so we can use this tool to create from scratch. We can create the labels that we need. However you're going through your document type, this is an interface that will allow you to create a project where you can pick things. I've already set these up over here, but it's very easy, fluid, to create a project from scratch and get them labeled to start out. Let me show, this is what I actually did this myself. So we've got different columns here roughly, and we're teaching the model that all the text in here is a line text description. This is the value. This is the units, and so forth. So there's going to be different use cases, have different classes. So bring your own sort of recipe. This is meant for custom recipes. We're learning there's a lot of traction with some common recipes too. So pre-built models in the supply chain are definitely showing interest as we've talked with customers. But this tool was designed to let you build document AI pipelines for the information within these documents that matters to you. With this interface, we get what we want to train the models. We get the text location. Let me show you what a more detailed one looks like in that way. So here, we see all the OCR tokens. We see this is the classification labels here. So I can see that I've got my line test descriptions. It's broken out into each token. And here's the token value. So the results of running the OCR process. This is all under one roof. We've got a lot of different things you can do within here to move to a data set that's trainable. And to skip ahead a little bit, not take too much time, you can see also that I've already run models against these. So I've created my labels, I've merged it in with OCR, and at this point I can train a model. And then this is, we can see the accuracy of that as well. With all the typical data science kind of ways where we're doing classification generally. So you're going to see some common precision, recall, F1 scores here by class. So you can see, you know, I've trained this on only 11 documents, nothing else, just 11 documents. And so what's happening here, it's already managing to learn the really dense type of data inside those tables. We need some more documents to be able to pick up some of the sparser ones. This is volume over here of tokens in the right to support. So these are the tools that we use to fight these problems over literally years until we kind of locked into the right technology. And we put that technology into the backend data science library we have. And that's what was released a few months ago. And now we've got this self-service user interface that sits on top of it. So we've got models. You can deploy into a pipeline. When it's all said and done. And that's the important part here, is that it scales. And so that we take in documents, whether it's a PDF or an image. A PDF is interesting to think about because that can be a multi-page PDF. So we're going to get one document with multiple pages. But the JSON supports all of that, shows you the boxes of what we label when we're doing prediction. So we can use one of the two different models. Different post-processings that we picked up too. We label everything's in tokens, putting those together, doing tables, line items, things that we're learning about as we talk with the different customers, all packaged into one pipeline that executes from top to bottom in a scalable asynchronous REST API. So with that, Vinod, or turn it over to any questions if we have them, but yeah, I'd be glad to answer like Dimitri in chat and something like that. But it's a new user interface we're launching this month and pretty excited about that. And you'll see more content coming out from us on this.
Thank you, Mark. Yeah, so this is, like Mark said, this is pretty exciting. We launched this last quarter and we've had phenomenal traction. And more importantly, we are able to now tackle a wide range of use cases that we didn't have before. So it's a great opportunity for us to understand if we can help solve some of your problems. So do definitely say it's a lot of good interaction on the chat, but please again reach out to us and about how we can help you solve your intelligent document processing use cases. What are the types of documents you have? And Mark said our solution is extremely flexible and we're able to tackle problems that are typically not answered by a lot of the out-of-the-box solutions. With that, I'm going to go to the next topic. So far what we looked at is a whole bunch of AI engines and tools to make your AI models. So it will be AutoML from Driverless AI or H2O open source, Document AI and Hydrogen Torch. They are all helping you take a wide variety of use cases, different type of problem types, and solve for building models. But the second part of the equation is once you build these models, you need to then start understanding those results, interpret those values, validate those models, then deploy them. So we'll talk about focus to a little bit about what do you do after you build those models. To start off, I'm going to invite Dimitri Gordev again to talk about model validation, which is a set of capabilities that we have been building to help data scientists understand if their models are actually good, if they're robust, and actually validate them. So over to you, Dimitri.
Thank you, Vinod. Let me start with the slides. So model validation is a relatively new topic to our tool set, I would say, but we're constantly working on it. And we reached the point where we have some sort of a beta version of a product. I would like to talk about it today. We're going to be working on it, improving it and extending it quite a lot in the upcoming future. And I think we'll be aiming at launching it largely later this year. So model validation is concerning pretty much any machine learning models. And I would point out like 4 different areas of model validation we're trying to focus on, and why we believe model validation is an important topic. First of all, assessing the models. Where I'm coming from is financial services industry, and in my past experience, we had a lot of pressure from regulators with regards to assessing them and validating the models we use from all sorts of point of view. So what we were expected to do was not only to assess how accurate the model is, but also to take a look at it from multiple angles. Such things as robustness of the models, what are the clusters of the data where the model is having difficulties predicting correctly, or things such as how accuracy is stable over time, because we're collecting data over time, and there are certain trends in the population which change over time. If a model has some assumptions behind it, whether they hold, and many more basically imposed by the regulators. But even outside of the financial industry, it is still a very important topic to keep in mind when you're developing a machine learning model and you're planning to apply it to your business use case. What do you expect in terms of the performance of a model in the future, and what are the inputs that would allow you to assess that more precisely? Because looking at accuracy alone might be misleading or might be insufficient, and as soon as you put your model into production, then you might face lots of different problems. So as soon as you focus on assessing the model from kind of a holistic point of view, the topic of validating or ensuring the model is fit for the production use is brought up. So typically in larger companies, there are independent teams who do that. So based on the assessment of the model, they put a stamp on whether the model is validated or whether it's not validated for production use, to have kind of a final decision in the process before the model is rolled out. During the validation and assessment, actually selection process happens quite a lot, because the model validation can be frequently an iterative process. So we build a model, and we see that it has a potential for certain issues in the future, like some of the key variables are really unstable, or they bring some instability over time, and we expect kind of the future customers to have a little bit of a different profile. So that might lead to iterations of retraining the models, changing the variables, including new ones or dropping existing ones. Which brings us to a set of models we have on the table to decide which one would go to production. And validating it from the point of view of assessing each of them makes this selection more transparent. So instead of choosing just the best model based on the accuracy, we're going to be using all important validation metrics here. We're talking about robustness, we're talking about complexity of the models, or anything else that is important for the use case, for the industry, and for the company dealing with the machine learning models. And last but not least is customization. A model validation should not be just a black box where you put your model into and you get a reply whether it's a valid model or not. It has to be very much customizable depending on the type of the use cases you're solving. So say time series problems, they require a different approach than just the typical tabular problems. If we're looking at deep learning models, then completely different set of techniques are required, not to mention potentially regulatory industries where there are regulations in terms of what to look at, which tests to run, and what metrics to look at are imposed by regulators. Having that said, let me switch to to the product we have on AI Cloud, which is dedicated to cover all these 4 areas. I would stress before switching to demo the customization part. So I'll be showing a couple of validation tests we have there. But the key stress here is that the way we build the tool, it's highly flexible in terms of adding new things there or changing the existing ones. So we maintain a so-called recipe structure in the tool, so you can bring your own recipe of a validation test or validation metric and extend the functionality of the tool. So let me jump and show you a couple of examples. So this is kind of a short demo where we have just a couple of experiments which we built, and we ran a couple of validation tests for them, just as a showcase. First one is Rossmann sales. I think it was a Kaggle competition back in the days. It was a prediction of a time series of sales across shops. So we start the validation process from looking at the model as it is. This model is coming from Driverless AI. So you see a lot of typical Driverless AI data over here. We're just copying it over just to have it in the same place where we'll have validation metrics. And what we typically look at is test score. This is RMSE. So how well that model performs on the test data, which is in this example typically more recent data sample, as often we do for time series analysis. And this is usually the number we use just to pick the model and what is the best model. But from model validation point of view, there are many other things we should probably take into account, starting with looking at the cross-validation score and the difference between the two. And another one which we rarely look at is a training score. So how far actually the training RMSE is from cross-validation or from test RMSE. And that can already drive certain conclusions, like how much test accuracy are we ready to give up to have a model which has closer training accuracy, so which is kind of less overfitted on the training data, or what would be the trade-off for us between the model complexity, say in terms of number of features used, or say in terms of the depth of the model we're building, and the test accuracy. Are we ready to sacrifice a little bit of a test accuracy, but to use a simpler model for the sake of it being robust in the future, or for the sake of being of needing less data to get collected to get applied? These are the basic questions we can start with when talking about model validation, but of course we go deeper into details. A very common and well-known technique is, to assess the stability of the accuracy of the model is backtesting, where we would like to see how this accuracy would have evolved over time if we would have had this exercise of building the model a month ago or 2 months ago, 5 months ago. So how the accuracy of the model actually evolves over time if we look into the past. And if we do so, that can give us approximately the idea of how this accuracy would extrapolate over the time in the future. And for this particular model, we actually see, on one hand, relatively stable performance over time, but with a few spikes, including the most recent time. And here, investigation usually starts. What causes these spikes? Are there certain data irregularities or certain periods of time which are not really representative, and maybe we should drop them? Maybe this spike was caused by, say, holiday season at this point in time, and we had higher sales than usual. So let's have a look at the distribution of the sales values of the target variable distribution. Were there any changes in variable importance when we're doing backtesting, or are we consistently saying that this feature and that feature are the most important for the model? These types of the analysis one can perform to assess how robust the model is, but of course it's just one of many examples. When we look deeper, we are probably interested in predictors as well. how the distribution of a predictor is changing over time. For instance, what is the drift of the features over time? Are there any features which shift quite a lot? We see one of the top features drifting over time quite a lot is holidays, which makes sense. Probably it's not worth excluding, but maybe there are some predictors we collected over time which changed the pipeline of collecting it or definition of collecting it, and therefore they're inconsistent over time. A drift detection would capture that, and we will make a decision of, say, dropping it, or maybe using a correlated feature instead of this one for the model to make it more robust in the future. We have a few other tests, validation tests here in the tool, but we're focusing on rather building more functionality around that, because bringing more techniques here will be and should be driven by concrete use cases, and will be implemented in a matter of bringing test recipes into the tool. So it's going to be quite an easy task to extend it. So these are just 4 examples of the validation tests we have for demo purposes. Let me also show you another one. Yeah, let's go back to Rossmann sales. One more task which you can be interested in is how different is our test data to our trained data. It's quite important for time series tasks because we're not sure if the population changes over time dramatically enough for the model to get invalid already a few months after we deploy that. So instead of looking at individual variables drift, we also have a test which has a single, which gives us a single number which indicates how different train and test data sets are. And this particular test requires building actually models. So we're in the background, we're spinning up we're using a driverless AI server to put together training and test data sets and build a model that would try to distinguish one from another. And the accuracy of that model can be a good indicator of how different the data sets are. We can analyze this model to get to the conclusions which are the features which had dramatic change, and then investigate what was the reason of it. Or we can have it as an indicator of the distribution changes over the entire population over time. Moreover, we have the functionality to compare multiple runs of the same test. Sorry, wrong button. Multiple runs of the same test automatically. And this way you can even monitor how your population changes over time in terms of this statistic, and see how the model you've already deployed to the production can be influenced by the population drifting over time. More functionality we have here, of course, includes comparing the models overall. So as I mentioned in the beginning, one might be interested in running multiple versions of different models with different input features or different modeling techniques, or maybe even using different tools. And eventually we would like also to include support of multiple model training tools here. So a user will be able to compare a driverless AI model to an H2O model and maybe potentially a third-party model. By not only looking at the test and validation accuracy, but also all the validation tests, including backtesting, drifts, similarity of the data sets, and other tests your use case would require. Let me stop at this point. Thank you for your attention, and please feel free to ask any questions in the chat, and I will pass it back to Vinod for the next speaker.
Thank you, Dimitri. Yeah, the model validation is definitely a big part of our AI capability suite. Because even as we build a lot of models, using all the different tools we talked about earlier, it's really important to make sure that the models we build are actually helping are effective, robust, and they are actually doing what they're supposed to do. Right? So all the tools that we talked about, like backtesting and research testing, those are critical for making sure that your models are actually ready to go to production. So once you're ready to go to production, what do you do, right? So that's where machine learning operations comes into play. So we have a full suite of capabilities on MLOps, taking your model all the way from model management, model registry to deployment and monitoring. So I'll introduce Abhishek Mathur here to come and talk about our entire MLOps offering. Abhishek.
All right.
Hey, Abhishek, you're on mute.
Hey, again, testing?
Yep, we can hear you.
Okay, awesome, thank you. Perfect, and yeah, happy to walk everyone through what MLOps has to offer, so let's get to it. So as I'm sure many of you are aware, H2O's MLOps is one of the most open and interoperable MLOps platform across the market. We allow our customers, and our customers use our product to manage their models at scale, having hundreds, even thousands of different experiments that are being managed within our platform. We have some of the most simple deployment options and some of the most comprehensive deployment options that our customers trust us with. And we also have our customers using our product for model monitoring, which is when the models are actually in production, how do you make sure that those models are performing well in terms of accuracy, drift, fairness, and bias. So considering all those different items, we are effectively looking at making our product, MLOps, more and more open and more interoperable, because that's how we believe we are able to democratize AI for all organizations. So having said that, let's jump into our MLOps segment. We'll go over some of the new features that we have released very recently. Then I'll be happy to show you a demo of each of those features. And then we'll end off with talking about what's coming up within MLOps. So firstly, what's new in MLOps? First feature that I want to talk about is our support for third-party model management. As I was saying in the introduction, MLOps is striving to become the most open and interoperable platform for MLOps in the market. And part of that is being able to allow our customers to choose where they want to use any particular modules of MLOps, use the tools that are really familiar for them. And today, we are starting our support for third-party model management platforms, where our customers will be able to store their models on any of the model management platforms that are available, while still being able to deploy their models with H2O's MLOps and monitor their models with H2O MLOps. This really enables our customers to get more flexibility and openness within their overall ecosystem, and they're not restricted to any particular tooling that they are not familiar with or don't want to necessarily move forward with. So H2O's MLOps really integrates well with other platforms, and model management is really the first way for them to do that. And today we are introducing our support for MLflow's model registry, and I will jump into a demo to quickly show that. So over here, what we've got is an experiment for wine quality prediction within an MLflow registry notebook right here. So what I'll do is just quickly run this as an experiment, such that this generates an experiment within our overall area. When this experiment actually finishes, we will see that experiment over here within our wine quality list. So just before this, I had actually, oh, there you go, it's finished already. So that experiment is now listed right here as the scikit-learn model that I just trained. In a typical data science workflow, what we'd want to do after an experiment has been trained and is ready is actually go in on this and register this experiment as a deployable artifact that can then move forward into an actual deployment. So from here, what I'm going to do is register this experiment in our model registry, in the MLflow model registry, and create a new model called, let's call it Product Day Test. And with that, we're just going to register this experiment as a model, and that's complete over here. So at this point, effectively, what we expect our customers to do is finish off their workflows within MLflow. And then at this point, what they will do is hop into H2O's MLOps, which can be accessed through the App Store right here as H2O MLOps. And they will enter this interface. And this is the main H2O MLOps interface. And for those that are not familiar with it, there's a ton of capability over here to manage their experiments, our own model registry, and all the deployments. So at this point, what I'm going to do is click on Add an Experiment, since we have registered an MLflow, a scikit-learn experiment within MLflow. I have a button right here for browsing of the MLflow directory. And I can see that the experiment that I had just registered, the product day test, shows up in my list right here. So I can easily click that, get the version number over here, select the version, and within a few seconds, that should be imported right here. Then within my experiments list, I can see all the experiments that have been added over here from our model registry that is in MLflow. And the same amount of metadata that you kind of expect coming right out of MLflow, you can view that right here as well. So within the parameters section, parameters tab, you can see the actual target column, and additional metadata that is all associated with the experiment is brought in over here. So at this point, what I want to do is go ahead and take this and register this as a model. And with a model right here, we can then go ahead with the deployment. So from the deployments tab, what I'm going to do is create a new deployment for product day test once again. Let's select a couple of configuration details. So the experiment that I had just brought in, it's all here. I want to deploy this into my dev environment, and just got to select some more configuration details. And just like that, I'm going to be able to create a deployment. A deployment that was brought in, an experiment that was brought in from MLflow. I was able to browse using the MLOps, the H2O MLOps UI, and within a few seconds, be able to create a deployment using that. And within 10 seconds or so, that deployment should be up and running. But in absence of that, I'm just going to show you what the final product will actually look like. So if I click on the actual deployment details, I'll be able to see the actual state of it, the deployment endpoint URL, which will be used to score on that particular model, and a sample request that I can just take this and use it as a curl request and send the data into, so I can see my model actually predict in production. And that's really how easy we make it for you to be able to bring your models from MLflow into H2O's MLOps and deploy that with just a few clicks of a button. And the model that I had deployed just now, that is now available as well and healthy, and it's got its own URL. That's the first feature that we really want to talk about, was the third-party model manager support. Moving forward, we'll be supporting other platforms as well, really just kind of starting off with MLflow's model registry. And that leads us to the next one. The next feature I want to talk about today is admin analytics. So this is an incredible feature for some of our customers that are mid to large organizations that have mid to large number of data scientists working in particular teams. And what this tool really allows customers to do is be able to get an organizational-wide view on the overall adoption of machine learning at their company. So users with the right level of permissions, they'd be able to view this particular application and get an idea on experiments. So how many experiments are actually coming in or being developed at their organization. They'll be able to see based off of projects as well. How many projects exist within your overall organization, and the count of how many deployments exist within each of the projects, how many models have been registered within each one of them. And then you'd also be able to see at a user level as well. how many or which users actually bringing in how many experiments, and those experiments, how are they actually moving down their overall life cycle, and how are they getting deployed into production. So having said that, I'm going to hop into my other tab that really shows you details on the admin analytics feature. So within the App Store, what I'm going to search for is admin analytics, and you'll be able to see this app right here. And once you open that, what you're going to do is end up on this app, particular UI and this particular interface. And within this, right off the bat, what you can see is on the dashboard view, we see all the experiments that have been generated by the H2O team within our company. So we can see a total of 162 experiments within this environment. 64 have been registered as particular model versions. 68 are actually deployed into particular deployments, and that's the same number for deployment of model versions and total deployments. So this is an incredible amount of information that we're enabling for our admin users, so they can see how many experiments are actually brought in and how are these experiments actually moving along into deployments. What I'll do is just quickly show you, so just sorting based off of the environment, this allows me to see what has been deployed. I'm just going to click on this experiment that has been deployed to dev environment. Details of this are actually shown here as well. We can see that this particular deployment has been scored about 20 times. It's in our internal environment, so that's not too large. But by clicking on this particular deployment as well, what you're able to see is all of the values that kind of went in and what the prediction score was for that particular deployment. So you're really able to dive in deeper on any particular deployment, get the scoring details that have been created for them, and see everything at a macro level as well for a particular experiment in its deployment, and then deployment to actual scoring data. So that's a dashboard level view that gives you that level of information. The next view I want to show is our project level view. And this view shows all of the different projects that have been created, along with who's the owner of them, and a summary of what really exists within these projects. So sorting on some of these, I can see that a test 3 project was created. There are 14 experiments in them, and there haven't been any deployments created from that particular project. So a little disappointed to see as an admin user, that's okay. But I want to see deployments as well. So going off of sorting on deployments, I'm able to see that this Titanic project within our organization has actually 7 deployments, and that's great. So I'm able to get that level of information for our projects as well, and really see which project is succeeding, how many experiments are actually in them, how many have been registered as model versions, and how many of them are actually getting deployed. So this gives our admin users more insight so they can take, or for their analytics purposes, or for them to take any kind of action on their side, whether it's to remind their data science teams to actually promote their experiments into deployments, or look at why is it that experiments are being generated but not actually being deployed. And the third view that I want to talk about, and the final view I want to talk about, is the user's view. And over here, any user that has been onboarded to the H2O MLOps platform would be listed here within your organization. And over here, what we can see is all the folks that are over here. I'm the first one, just kind of looking at it, sorting by the owner alphabetically. How many projects I've actually owned, how many experiments I've got, and the overall life cycle of those projects. So I just want to see from the H2O organization, who has contributed to experiments that have actually been deployed into production. So I'm sorting by deployed to prod, and I can see that some of our data science team members, they are the ones that are actually adding experiments and deploying them into production environment, which is good insight for me to have. And this is really a powerful tool that we allow our customers to use such that they can get the insights that they need across their organization and really see the adoption of machine learning within their companies and organizations. So with that, that's really a quick overview of H2O MLOps admin analytics. If you have questions about either of the 2 functionalities within MLOps, happy to answer them within chat. And now what I want to do is quickly dive into what are some of the more exciting things coming out in H2O's MLOps. So the first feature that we're looking at adding is experiment tracking. Experiment tracking is a capability that allows our data scientists to track a lot of the relevant metrics and artifacts automatically, irrespective of where the experiment is actually trained. And this allows us to capture a much more richer metadata for your experiment, capture that and use that within the overall H2O AI Cloud to enrich the experience that we provide by having more details about the overall experiment that was created. Our customers would be able to use that to visualize the results for experiment tracking details, or you can pull that data raw from there directly and be able to use that for whatever purpose it is on your side. So experiment tracking is a feature that we're super excited about and looking forward to getting that into hands of our users. The next one is an enhanced way to monitor your models. So our customers have already the capability of seeing their deployed models in production and being able to monitor those. What we're going to be enabling with this is a single and seamless interface that allows you to go from management to deployment and monitoring of your model, and adding in some more capabilities around feature importance and explainability and operational infrastructure metrics, along with the drift and accuracy that we provide right now. That's really going to make model monitoring a powerful area for our, not only the data science teams, but also the machine learning engineering and DevOps teams that are managing infrastructure for deployments. And the last feature that I want to talk about that's coming up soon to H2O MLOps is being able to monitor any third-party deployments. So once again, as part of the open and interoperableness of H2O MLOps, we want to allow our customers to be able to deploy their models anywhere that they want. If it's on the H2O infrastructure, great. If it's not, that's perfectly fine as well. And obviously, with the enhanced monitoring capabilities that we're going to be adding in, customers want to use our monitoring platform to monitor their models, irrespective of where they've been deployed. So third-party deployment monitoring will really allow our customers to deploy the models anywhere and bring the monitoring capabilities back into H2O's MLOps. So that's really at a very quick overview and highlight of what we're looking at bringing into H2O MLOps very soon. And if there is any feedback or any comments on any of these, please feel free to add them into chat, and we'll answer that there. And with that, I will pass it back to Vinod so we can get to the next segment.
Yeah, Abhishek, from one presentation. As Mike mentioned, we have added a ton of capabilities, and this is part of our entire ecosystem of helping customers wherever they are, whatever environment they're using, whatever modeling frameworks they use, still be able to deploy and manage the entire AI infrastructure. So that we got to the make and operate part. Now let's get to how do we innovate, right? Do build those models, build these experiments, but how do consumers, or more importantly, business users consume them? For that, we've introduced a year and a half ago a low-code development framework called H2O Wave, which has been extremely popular amongst data scientists and developers who are building a lot of really cool applications out of this. So I'm going to bring back Michelle Tanko here to talk about what are the new innovations in H2O Wave, and then we'll talk about the App Store itself. So some of these applications that we are building and our customers are building, they are in the App Store. We'll talk about what innovations there are coming there.
Everyone, again, I'm Michelle Tanko, and I'll be talking to you about first our app development framework, H2O Wave. Well, Wave is a tech stack that allows you as a data scientist or someone who only knows Python and maybe isn't a full stack developer, it allows you to build real-time interactive web apps or dashboards using only Python. So this is for data scientists or other users who have built models. They have information they want to share with business users, but they want to build an interface that a business user can use. Everything is done in Python, so you have access to pre-built cards and components for building your own app in your own company's theme and so forth, and everything is done in Python. We have features here for real-time sync, so everyone can get live updates at the same time. It is interactive, so you can, we'll look at several widgets today where you can click a button and you have menus and so forth. Users can collaborate in the app, so you can very easily build multi-user applications where users don't step on each other's toes, but they're able to integrate together in a single app. Excuse me. And we also allow you to develop and deploy quickly. So we'll look at examples of that today. So what is new with H2O Wave? Well, the first two items I'm going to show you a demo of and talk about is for anyone who's used Wave previously, you'll know that the setup on your local machine took several steps to get started. And now this is all done with a single step. You install the Python library you need, and then when you run your apps, you automatically get your content server and everything that you need to get started. So I'm going to show you how that works, but first I want to mention the IDE hints for PyCharm. They're released today. VS Code is coming soon, but essentially we're going to have access to template starter apps directly in our IDE. We'll have snippets for our Wave cards and components so we can build things really easily. And then we also get autocomplete on all of our Wave specific code like user dictionaries or objects. So it makes the process of writing apps and getting started a lot faster. So let's go ahead and show how that works. I'm going to jump into PyCharm. Here is an IDE for using Python. You can use your favorite IDE, or maybe you just like writing in VI if you're really cool. But anyway, today I have a brand new project, and I do have a Python environment, but I don't have anything installed in it. So the first thing I'm going to do, this is a little bit more for my technical folks, but I'm going to install the H2O Wave package into my Python environment. All right, and it's going to go and pull this library and install it for me. If I check here in Ben, we'll see that I have my Wave server with automatically installed. So now all I have to do to get started with Wave is right click. I'm going to create a new file. I'm going to call it apps.py. And I have an empty file here. And now we need app code to run. So I mentioned the snippets or having code hints and code complete directly from your IDE. So I'm going to type W, and I get access to a lot of different things. The first one that I might regularly do for new projects is base app. So this is sort of the skeleton, the simplest skeleton for a common Wave application. And then I just have to fill out any code that I might want here. But I'm going to actually do a different template. I'm going to do the app header. And this is a standard application that has a header at the top, a body in the center, light and dark mode, that then as a developer, I can go add my own content to. So we'll see what this looks like. I'm going to come back down to my terminal and I'm going to run this application. So I'm going to go into my virtual environment and I'm going to use the command wave run app.py. This will automatically start the Wave server for me and start the application. So now when I go to my browser on my local machine, I go to localhost 101.101. And this is the sample application that came with the Wave snippets. So you'll see I have a nice header card at the top. I have a content that takes up my whole page and a footer. And if I wanted, you can see a little bit of the interactivity. We have a light and dark mode, for example. So then as a developer, I can go ahead and update this template with some of the actual content that I want to show my end users. Maybe I'm connecting to a model, maybe I'm exploring a data set that was in my drive, or whatever else. Some of the other snippets that are available, we talked about how this is an example app, but we also have for all of our components and cards, more information. So let's say that I want to have a new card, and I know that I want it to be a plot card. I want to show some sort of bar chart or line plot or something. I can type wplot, and then I have access here to either the plot card basic minimum. This is like everything that I need to make a plot work. And you'll see that it's a location, a title, and some data. Or I can use wplot in full, and this gives me access to everything that's possible as a command or as a parameter to this object. So if I'm using a new component or card for the first time, I love this feature for seeing everything that's available really easily, and you get all the options. In addition, for anyone who maybe has used Wave before, we have the idea of the interactivity. So for example, when I was in this application and I clicked that I wanted to go to dark mode, my server code was called, and then I had written code in this template that said what to do. So one of the things that we have with snippets available for Wave now as well is anytime you try to access those parameters or those interactivity options, the snippets know about it. So if I try to look in my query arguments, I have a list of, there's only one interactive object here, and it's called change theme. But if I'm building a really complex app that has like 50 different buttons and I have to remember all the names of them, it can be complicated. So snippets make this even easier. You get a drop-down list and you can pick the part of your code that you are trying to reference. All right, let's go back to our deck. I'm going to go ahead and kill my application. All right. One of the other things you're hearing on the Wave side is that when folks got started with Wave, they really enjoyed it, but the learning curve was a little tricky. And so part of the snippets install that I just showed you to make that process as easy as possible, we've also been working on new documentation to help everyone understand how you might want to be using Wave. So I'm going to go to the Wave docs, wave.h2o.ai, and I'm going to click on the widgets option, which is brand new. And here there's an overview that gives you some information for getting started. But in the content area, I'll go to header card. And here for, you'll see lots of different widgets on the side. We have the most common ways of using these widgets, what they'll look like and what. So for example, what we've seen the most common header card being is having a company logo at the top and then a title and subtitle. But maybe instead of a company logo, you want to use an icon. Well, here's the code for that. Or maybe you want your header bar to have navigation. So you can click here and go to different places in your app. Here's the code for that. Even more, you can have some sample links at the top, and here's how you do that. So this is available for almost all of our widgets. You can go through and understand, how do I use tags? What does the code like? What's common ways of using these components? And it's a nice way to get started or understand what's available for in your applications. All right, the next thing I want to talk about is themes for our Wave apps. So we saw in our example app, I'm going to go ahead and run the application again. We saw in our example app that there was a drop down where we could have light or dark mode, but we might want to have different themes. Out of the box, there are several different themes available, and you can find these in the documentation. But instead of using the light theme as a default, maybe I want to use the actually, here's a nice snippets demo. It will show me the themes that are available. Let's do Ember, that sounds nice. So I'm going to update my code, go back to my app. And now I can see that this is in a new theme called Ember. So these themes are available in the documentation and you can understand them. But maybe you want to build your own theme with your company's colors and so forth. Well, we have an app for that. So inside the documentation and in the Wave server, whenever you download it, there's an app called Theme Generator. So I'm going to go ahead and show you what that looks like. I'm going to use the Wave command, fetch, to download a bunch of examples so that they're available on my local machine. I don't have to go look at them in the documentation. And then I'll see here that now I have the folder called Wave, and in that there's a bunch of examples. So one of these examples is the Theme Generator app. You can see there's a lot of examples. Here it is. So I'm not going to run the app on my local machine because it has some imports I need to do first, but essentially you have this available on your local machine if you want it. So I'm going to jump back into my AI Cloud that we were looking at earlier, where this app is running, and I'll go ahead and visit it. And this is the app that you have available. So this is our tool for letting you build your own themes for Wave. So there are 4 different colors that you can customize. For example, I might want to make this in the H2O brand, which is that hex code. So now I can see the nice H2O yellow. And what's really nice about this is it helps you, we're not all UX developers, maybe none of us are. It helps you understand if this is going to be easy for your end users to read or not. So for example, we're getting a warning that maybe the yellow and the white aren't really have enough contrast between them. My plot down here looks really great, but trying to read this button that says primary is a little bit tricky. So maybe this tells me that I want to change one of these colors. But let's say we built a theme and we really like it. All we can do to use it in our app is we'll copy this and we'll go back to our app code. And I'm going to say that the theme I want to use is H2O, but I'm going to actually add my theme here, and I just need to actually name it H2O so it's usable. All right, and then I do need to run my app again, and we'll go back. Uh-oh. Oh, I forgot a comma. This is how you know it's really a live demo. Okay, there we go. Now our example apps in our nice new H2O theme. So the idea is you can make your apps feel and look like your company's brand really easily now. All right, we'll go ahead and stop this app. And again, everything we've been looking at so far is already available in Wave. These are new features that have come out in the last couple of months. And the last thing that I wanted to let you know about that's available today is we have some new app templates. So if you want to get started with apps, although in the snippets there are some like sample layouts and common use cases, or there's sample layouts, but in the app templates we have common use cases. So I'm going to go to GitHub, and I'm going to go to the open source Wave apps area where I have several example applications to help me get started. So we have some applications that are hard-coded to a specific data set and give you an idea of what you can do with Wave and with machine learning. For example, the credit risk application is something that sits on top of a model that's already been built, and end users can review the predictions, look at the Shapley codes, which Megan talked about earlier, and then understand if they want to believe the machine learning model or overrule it with their business logic. So there's lots of different use cases here to understand what's sort of available, but what's new is we have a couple of templates. What the templates are is these are not hard-coded on a data set. They've been written so that they can work on more or less any data set, and all you have to do is update a configuration. So what does my single predictions from MLOps do? Well, I'm going to show you. So it is this application. Let me just refresh, clean it all up. Okay, so this application, I have given it a deployment endpoint from MLOps. You'll remember that Abhishek showed us that just a little bit ago. And from that deployment template, this application is finding out exactly what fields the model has and dynamically building an app that you can fill out to make predictions. So for example, I could say that the state of this person, I'm doing predictions for telco churn. So this end user is in Kansas, and they've been at my company for maybe 100 months, and I can make a new prediction. Right now it's 1409, and now you see it's 14.20. So this is an example template, but we can go in here and we can edit the application. We can change the title to our specific use case. And I could go to MLOps, look at any of my deployment endpoints. I'm going to just copy one from here. And you'll see that my application, there it is. My application is currently, it has state and account links, but I'm going to save this app. And now account length is at the top, international plan. I've sort of changed the use case dynamically. So if this is a type of app that's interesting to you, you can use it today with no code. All you have to do is, looking at this template, go into the app HOML, which is our configuration file, and change this information. You can change the theme you want to do, what your logo is, and then what your MLOps deployment is. We have a couple other templates. One is for exploring data, and one is for using the open source library Pandas data frame describe to understand data sets more. But we hope that this helps you get started with building apps. All right. So now we're going to talk about what is coming soon with H2O Wave. So there's three items that will be helpful for our developers. We're going to demo one of them today. So I'm going to talk about the second two first. We've had a lot of requests for being able to zoom in on tables and have automatic interactivity there, so that's going to be coming. And then there's a component called toast notifications. If you're not a UI person, this might be new, but essentially whenever you're on like a website and a little notification like pops up, stays for a couple seconds and goes away, like a piece of toast, maybe that's not why it's called that. But anyway, that component will be available. The big component I'm going to demo for you today that's been a lot of requests, and I think maybe a couple people will be excited about, is server-side tables. So today in H2O Wave, when we are using any of our components, we're sending all of the content from the server to the screen to be displayed. And in a lot of cases, that's really great. But let's say you're building models in H2O3, which is our distributed machine learning platform. You have millions of rows, and you want to be able to show some of them to your users. You do not want to send millions of rows onto the UI screen. The application is going to totally crash. So UI tables allow you to tell Wave, I want to build a table that has pagination. I want to do all my searching and filtering and everything else in my backend service. I don't want Wave to try to do it on the front. So let me go ahead and show you how that works. All right. So here I have another application. I'm not going to talk too much about the app code today, but just know this is a template that when it's released, you'll all have access to, but we're going to focus more on what it looks like for our end users. Okay, so in a Jupyter notebook, I went ahead, I am running an H2O cluster on my local machine, but maybe I should be running, or maybe I could be running this cluster in the cloud like Megan showed you earlier, maybe it's running in Hadoop. But I have an H2O cluster, and I went ahead and just created a fake data set that's 1 million rows long. It has 5 columns, and some of them are categorical and some of them are integers. So your data might be really big, but this is just sort of an example to show us how it works. So in my application code, I am pointing to this H2O cluster, and I'm telling it about this H2O data frame. But the Wave app and the backend H2O cluster are completely separate from each other at this point. Here you can see on the screen, my Wave table knows that I have 100 or I have 1 million rows, but I can only see 10 at any given time. And when I go ahead and click next on the table, it gets me the next 10 rows. And so for each of these calls, it's actually talking to my backend database. Well, not database in this case, it's an H2O cluster, but it could be like a Snowflake database or something else. And it's getting the rows that I need. Where this can be really nice is for searching, filtering, and other things. So let's say I'm only interested in rows that contain some key phrase. And in this case, my key phrase is going to be 74. So we went down from 1 million rows to 29,000 rows that in one of these columns has the number 74. So then my end user says, okay, but I want to filter a little bit more. I only want rows where column C5 has this specific value, okay? You can see how quickly this filtering is happening. Now the filtering is happening so fast because my H2O cluster. Wave is not doing this work. This is sort of our integration piece. But the filtering on big data happens really quickly. I can do search. I can sort my remaining 191 rows. And now I have the smallest on the top and the largest at the bottom. So if this is interesting to you, it will be available super soon. I think it's already in Nightly, so you can start using it. And we have examples. So if you want to specifically look at this H2O3 example, we also have a Pandas example. You can use that to get started. All right. So at this point, the last thing I want to share with you about H2O Wave is the Wave community. So Wave is completely open source. We've talked a lot about different products today that are proprietary at H2O, but Wave's an open source platform. The source code's completely open. You can go look at it. You can make a PR. But here's some links that might be interesting to you. So screenshot them if you want. The Wave documentation, which has that nice new widgets feature, but also explains to you how to get started, how to build your first app, what to do to get going. You can check out the source code if you want. Look at what's coming next. We have our roadmap there under milestones. If you have questions about Wave, maybe you're trying to do something and it's not quite working how you want, or maybe you have an idea for a new feature, from GitHub, we have a discussions panel. So you can go there, you can show off the cool new apps you're building, you can ask questions, you can talk to other community members. We'd love to see you there. If you want some resources to learn more, I recommend the blog on the Wave docs. So I will actually pitch this one a little bit. If you go to the blog, We have every release or every big feature. We have a detailed blog that explains to you how to use all the new features and why they're exciting to you. And then there's also a blog called Learning H2O Wave, and it has just a bunch of links and community resources and gives you a suggestion on how you might want to get started learning it. So this is a nice place if you want to know more, but you're not really sure how to get started. And then the last thing, we looked at the Wave apps repository in GitHub already, but this has a bunch of open source example apps and templates to help you get started using Wave to build your own apps. All right, at this point, I'm going to hand it off to our next product team, which is still me, and we're going to talk about the H2O AppStore. So what we just did was talk about Wave, which is H2O's way of building applications, and this is more for our technical users, our data scientists, folks that want to build apps themselves. But now we're going to pivot a little bit, go back into the AI Cloud UI, and we're going to talk about the App Store. The App Store is a place for your developers to publish their applications, but also for your end users to browse applications, use apps, share apps, and so forth. So what is the App Store? Sort of just already said this, but it is in the H2O AI Cloud, and it's your organization's home for AI apps. Some of these apps are available from H2O, and you've seen several of them today, like model validation. There's going to be another one later called AutoDoc, but also your developers can build their own apps. So developers can build apps using H2O Wave, for example, and upload into the App Store to share with other users at the company. Your end users can browse the apps in the App Store, look at what's available, see what's new, but they can also manage their instances. So a lot of the time, maybe our admins, for example, really don't want apps running when no one's using them. So as an end user, I can go and turn my app instances on or turn them off and so forth. And then the admins have control in the App Store for who has access to what. So some apps might be particularly secure and you only want a certain group of users to see them. All of that can be done using tags and roles. And if there's something you're interested in, let your H2O person know and they can tell you more. All right, what is new in the App Store? So the first thing I want to talk to you about is managed versus on-demand apps. And I'm going to close my Wave tabs and switch to my App Store tabs. And let me tell you what manage and on-demand means. So when I'm in the App Store, usually as an end user or as a user of apps, what I might do when I go to a specific app is start my own instance of the app. What an instance means is that the application is actually running. So think of the idea of having Microsoft Word on your computer versus having 4 Word documents open. Each of those Word documents is an instance of Word running. So just looking at this app in the App Store, this is the application and what I would have access to. But when I actually run the app, that's an instance of it running. So a lot of applications or a lot of developers might build apps such that each person runs their own instance. For example, I can see here that there are 11 instances of this app running that are public. There might be more instances that people are running privately because they don't want to share them. But these are 11 instances of the app running. And if the app is up or not, maybe I could go visit that. I have an instance, so I have access to go run it, or I can write my own. This is sort of our standard practice for apps. We call this on demand. However, we have a new feature called Managed Applications, which allows a developer of an app to say that they have actually built an application to be multi-user and that there only has to be one instance of the app running and all users can share it together without sort of stepping on each other's toes. So an example of that would be our MLOps application. You'll notice here, if I click on App Instances, I am not the owner of this instance, someone else is, and I have no option to run the app. I can only visit it. So this is really great for our end users because you save the step of having to create your own app instance. You can instantly visit. You don't have to wait the 30 seconds or so for an app to start when you spin it up. But it's also really great for our admins. It saves resources. If you have an application that can be built using multi-user and you have 50 users using it, that saves you 50 instances of resources. So each resource is maybe a quarter of an AI unit, so that can be really big savings. So this is probably most exciting for my admins, but you now have the ability to have managed apps as long as your developer builds the app to be multi-user. All right. The next thing I want to talk about is aliases for apps. Oops. So I don't know if anyone noticed, but when I was looking at the theme generator, for example, and I went and visited the application, oh, it's being a little cranky, isn't it? Okay, I went and visited the application, or I didn't, that's fine. I'm gonna click on my instances and visit a different application. We'll go to the MLOps. I feel like I have some security thing happening right now. Okay, well, where I'm going with this is that when apps are running, there we go. You may notice that the top is not particularly attractive. So this is a unique ID, a UUID, and every application instance has its own unique ID. And in a lot of cases, this is totally fine, but there might be instances where you want a permanent address. Say every time there's a new app instance, you don't want to have to, in your backend processes, update the URL, or you might want this to be more end user facing if it's a particularly important demo or application. So this is now available with a feature called aliases. And to show you an example, I'm going to go to the H2O website, and I'm going to click on solutions. And here you can learn everything about what H2O does, but I'm going to specifically go to this hospital simulator. And this is going to redirect me to, it has some Google Analytics, but to chos.cloud to H2O AI. So I'm not going to demo this app. Nikki's going to talk about healthcare later. But essentially, you'll notice this is going to be a prettier URL. It's static. Anytime there's a new version of this app instance, the URL doesn't change. It just automatically, based on a little command line from my developer, points to the appropriate instance. So this is really nice for anytime you want something a little bit more permanent in an app you're building. All right. Oh, and the last one is very little, and I wouldn't necessarily normally mention it, but several people have asked recently. So I'm going to make sure you know about the latest names. So when I am looking at my apps in the App Store, for example, text data labeling, applications have versions. So whether there's a new feature or a bug fix, developers can update a new version of the app. And when you're in the App Store page, when you click, it will always take you to the latest version. But here I have a drop-down list, and I can see that this specific app has a lot of past versions that I might be interested in. But where I'm going with this is that the URL is, again, a unique ID for each of these versions. But if you were to use this link in some other process, like say a Confluence page of apps you want to link to or something, it needs to be updated every time there's a new version because the UUID is directly linked to a specific version. So if you want a stable URL that will never ever change, there's this feature down here called the app URL, and you can copy this. And now that will always take you, you'll notice I'm on version 0.10 right now, that will always take you to the latest version. So that has redirected me to the latest version, which is 10.6. So for a couple places, this can be really helpful. So I wanted to mention it today. All right. Finally, I want to talk about what's coming soon in the H2O AI Cloud. And there's two main things here. One I'll demo and one I won't. The first is the H2O Marketplace. So this is going to be most exciting for my admins. So if you're the admin or owner of an H2O AI Cloud and you want to know more about this, please let your H2O person know. But Marketplace is basically an interaction between H2O and your hybrid cloud environment so that you can easily get updates on apps. So let's say you have the MLOps app from us and there's a new version of it. Via Marketplace, admins will be able to see anytime there's new versions of apps, and they'll be able to see apps that are installed in their environment from H2O and click a button to, in a lot of cases, get either the install done for them or a list of steps. Sometimes our apps have manual steps that need to be done, like you have to configure your own S3 bucket for security, for example. But the install instructions are provided and so forth. Admins can also browse the new apps available from H2O. So we're always putting out new stuff, and the owners of the App Store can see what's available and if they want to install it or not. So that's a feature that will be soon. Again, most exciting for my admins. The last thing I want to talk about is Jupyter Labs from within the AI Cloud, specifically the App Store. So earlier today, if you've been with us the whole time, we looked at the platform token, which allows you to use all of the APIs from the AI Cloud from your local workstation. But there are times when you don't necessarily want to have Jupyter on your local workstation. You want to be directly in your own environment, and this is where the Jupyter Labs can app can help us. So I'm going to jump back to my cloud. And I have this as a pinned app because it's one of my favorites, so I'll go ahead and view it. And here I actually have multiple instances. Actually, I want to show that way instead. So I'm going to go to my instances. This is all the apps that are running that I specifically own, and I'm going to specifically filter just to my Jupyter ones. There we go. So you'll see here that I have 3 instances of this notebook. I know we haven't looked at it yet. We will in a minute. And 2 of them are public, which means anyone that goes to the Jupyter app, they can see my my notebooks, and they can go in and they can look at them. And I do this for sharing notebooks with people and collaborating. It's really helpful. But I also have a private instance, which is only me, because these are things that I don't want other people to touch. So this is one of the nice features of the AI Cloud, and with notebooks specifically, you can have work you want to share and work that you don't want to share. So I'll go ahead and go to my AI Cloud. And this is an instance of Jupyter Labs running with connections to our different APIs. So for example, this is a notebook, this notebook is up. It's using the platform token that we talked about earlier, but it's a tutorial for connecting to driverless AI. So it has the specific, by default, it's going to use what the environment I'm in. Every environment is going to have its own token URL, its own client ID, but I'm running in this environment, and I can connect and I can go to driverless and so forth. This is a standard Jupyter Labs. So if you're familiar with Jupyter, you can make notebooks, you can share links to notebooks with folks as long as your app instance is available to them and so forth. And we're really hoping that this helps our developers who maybe don't have access to Jupyter on their local machines get started using the cloud and interacting with all of our APIs. All right. At this point, I'm going to hand it off to the next person to talk about our next product. But if you have any questions, please put them in the chat.
Thank you, Michelle, for the wonderful demo. So just to reiterate, like what Wave and the App Store are bringing a whole series of applications for technical users and also business users, right? Most important thing is, I think some of you might have noticed this, but we actually use Wave quite a bit ourselves internally. So a lot of the team-generated apps, all that Michelle showed, mentioned that. You probably noticed MLOps, which Abhishek demoed earlier, and then Hydrogen Torch that Dimitri demoed earlier. Those are all built with H2O Wave. So we actually can build like anywhere from like simple apps to really sophisticated workflows, also H2O Wave. And it allows our customers to go from like simple use cases, business-facing use cases, to actually sophisticated workflows all through Wave. So do check it out. And I think all the tooling that Michelle demoed earlier, that's going to make it even easier to get started. So if you have been like sort of on the fence or been trying to figure out how to get better, this will help you get there. With that, I'm going to hand it over to Chris Simmercat, who's a product manager on the team focusing on financial services, H2O AI Cloud for financial services and specific applications for that. We're going to talk specifically about a product called automatic documentation, which has been available in the H2O suite for a while, but today there's a new update in the AI Cloud. And let Chris talk about why that's really interesting for financial services customers and also for other regulated industries. So over to you, Chris.
Hello there, thank you. Share my screen here. So today I'll be talking to you all about our AutoDoc Wave app. And like Vinod was mentioning earlier, in several regulated industries, there are regulatory requirements to have model documents, part of what's called model risk management. But outside of just regulated industries, it's generally best practice, and it's important for reproducibility concerns to be able to document how a modeling pipeline was constructed and how you ended up with the model that you were running with. Our Wave app here uses both the Wave framework to provide the visual layer, and then it's also using our standalone AutoDoc Python module as the backend piece to take telemetry that's recorded for a model, as well as the template for the document and then renders that into either a markdown file or into a Word document that you can download, and also renders it in the app for you to look at, which we'll show you in a bit. This kind of provides just a very standard and repeatable way to do supervised learning, model training, and validation documentation. And currently we're supporting H2O 3, the open product, as well as Driverless AI. And we're announcing that, we're adding third-party support for Python scikit-learn. That way you can get a lot of efficiency through the templating and automation. So what is it? I just sort of explained it a bit to just visually kind of see, and we will go through a proper demo shortly. Just to give you a general sense though, some of the problems with documentation without an automation tool is that the modeler just has to capture all kinds of telemetry. What was the environment it was set in? What version of Python am I using? What version of scikit-learn? Which class am I importing? And all those sorts of nuances, as well as the model metrics and the training and test and validation splits. And it's a lot to capture. And so what happens when you're using our cloud is that you can capture these things in a more automated way, and then we will generate an automated document for you. And this just gives you the greater accuracy and consistency. There'll be collaboration, and just particularly for regulated customers like in banks and insurance, having that sort of like consistency as well as automation is pretty critical to having a repeatable process, which is key to meeting your regulatory obligations. So right now, we currently support models that come from H2O 3. These are mojos that are getting imported in. We also support from scikit-learn classification and regression models all across them. And there's a list in our documentation around the specific ones. And then we have expanded support for driverless AI. Certainly earlier, you would have seen driverless AI had an AutoDoc instance inside of it that uses the same Python engine to do it within the app. You can also use the Wave app to access your driverless instance to then extract and generate that AutoDoc from your experiment. So let's take a real quick look at an example using scikit-learn. So this is the prostate cancer data from the UCI machine learning library. And this is just a very simple logistic regression model developed in scikit-learn. And I'm actually using the Jupyter Lab instance in the cloud that Michelle alluded to earlier. And so if I want to document this model, once we ran the model, I need to create a pickle and joblib so I can download it. And then I can get into, you can go to our apps. And so you can look for it just by searching for AutoDoc. And here we are. And so I already have an instance running, so I'm not going to try to create another one. I'll walk you through the process real quickly before I kind of jump into one that's already been pre-generated. So for report type, we're going to create a scikit-learn. And let's just, for the sake of argument, we're just going to call it sklearn because it's coming from sklearn. You'll import your pickle. So go to wherever you're storing your pickles. We prefer the joblib format, but pure pickle format is also okay. And then also to do some of the telemetry, you need to upload some of the data that you're using so that we can do some performance metrics. Now, since in the sake of the workflow that I'm demoing here, I'm comparing several different outputs from driverless, from H2O 3, and from scikit-learn. I'm not going to do the testing because I might have been planning to do out of time sampling separately. And if you're interested, there's some advanced configurations in here if you wanted to override any of the defaults. We don't in our case, but you should know that that's an option. And then you can create the AutoDoc. Now, like I said, I've already generated one of these, so we'll just go ahead and jump. This might actually render very quickly, so if we can do it, we'll jump into the one that I already rendered. So this is the web UI that shows the AutoDoc format. So there's the experiment overview, data overview, feature importance, final model, alternative models, partial dependence, and the appendix. So these are the exact same things that you'd seen in previous forms of the document. And then you have the PDP plots and Shapley values. And then you can also you can download a copy of it as a Word document. And you see the same Word document format contains the same artifacts that we just saw in the web app. So that's a quick overview of what's there, and we have detailed documentation online. And just to kind of preview what's to come ahead, we are adding more support for H2O 3 in particular for Steam managed instances in the cloud. So that way you're not just uploading mojos, it'll give you some greater flexibility in terms of some of the features there. We'll be expanding our support for scikit-learn and adding additional modeling packages. We're thinking along the lines of StatsMod and some of the deep learning frameworks. And then additional support for customization of the templates. If you're familiar with the Python engine that exists today, you can already do that as a markdown file as your template. And so we're just getting the front end on parity with what the engine is capable of. And with that, I will pass it on to the next presenter.
Thank you, Chris. Again, I think, again, if you want to try, all of these apps are available in the H2O AI Cloud today. So you can go and try it out, go sign up for the free trial and then use it. And then if you want to do a deep dive, do reach out to one of us or to one of your, who you're talking with at H2O. Our sort of final presenter for the day, we're going to shift from financial services over to healthcare. This is a vertical that's very near and dear to us. Part of the mission of the company was to do AI for good, and we've invested over the years a lot into making sure that our platform can be used to help improve healthcare across different domains. So we work with all kinds of different health providers, payers, insurance companies, pharma companies. And I want to introduce Nikki, who's our product manager for the healthcare vertical, and she's going to talk about some of our innovations and also our efforts to work with different sort of players in the healthcare space. Over to you, Nikki.
Thank you very much, Timo. Hello, everyone. My name is Nikki. I'm very excited to be talking about our H2O Health initiative. In H2O, we have 10 years of healthcare experience, and within that, we have actually worked with more than 70 healthcare organizations in 12 countries, including North and South America, Europe, and Asia. Within that experience, of course, come hundreds of healthcare problems that have been addressed with H2O capabilities. If you are interested, for the interest of time, I'm not going to go into too much detail about our previous use cases. But if you are interested, I invite you to visit our healthcare page. From our homepage, you can go to Solutions Health and scroll slightly down to our use case catalog. With a very simple registration, you can actually access the more than 100 use cases I have been talking about and go directly to the app, to the solution that perhaps you are interested in and find out more. You can also, of course, reach out to us and we can discuss more in detail. I will talk about the solutions that we have actually worked into adding in our App Store. So we moved from ad hoc solutions through this experience we have been having with customers to actually creating reproducible and domain-specific pipelines. Again, let me switch view to our App Store that Michelle already introduced. If you have access to our public App Store, please visit our healthcare tag here and explore the various solutions we have developed already in all fields of payer, provider, pharma, and population health. For this discussion right now, I'm going to be focusing on two solutions. One is the COVID-19 Hospital Occupancy Simulator. It's a mouthful, so we like to call it CHOS. And the Gene Mutation AI. Let's start with the COVID-19 Hospital Occupancy Simulator. Of course, everyone is very well aware of the pandemic that has been tormenting the globe over the last 2 years. And with that, we were actually called to help healthcare providers to predict and prepare for the next COVID-19 wave. This app was prepared with a big healthcare organization of the US. And in essence, what it does, it offers simulation-based ICU and non-ICU facility occupancy projections. We are integrating county-level predictions of COVID-19 cases, and we consume facility-specific historical data or create appropriate geography-appropriate estimates, and this talks to the social determinants of health for those in the field. Of course, we also can integrate real-world evidence in the app and in the simulation, and this can be public or proprietary. I'm going to switch to the specific app. This is also the solution that the app that has the alias that Michelle demonstrated earlier. So feel free to visit directly chos.cloud.h2o.ai and play around with it. We offer various explanations, both about the overview of the app, what it does, but also a little more about the algorithms and the simulation that are running and the data that is running behind it. I'm going to go straight to the simulation page where you see that we have the ability in this version of the app that you see now to use public information about historical hospital occupancy trends in specific counties. Here I have selected Massachusetts and the Suffolk County, which is the Boston area. We have a drop down all the states and all the counties in the US. I will direct you first of all to the output of the app, which is in essence, with the dashed line you see here, projections of occupancy in non-ICU and ICU wards. And this can be very important in the decision about staffing, making beds available, and anticipating the volume of patients with the next COVID-19 wave. The app is informed not only from the hospital, historical hospital information that you see here actually for this specific county. This is the average per hospital statistics over the last 4 weeks, and this is what the app is consuming. But also we're consuming a model that offers forecasts about COVID-19. Here we see that, of course, COVID-19 is on the decline currently, but we still have quite a few cases, and we might be interested to know what to expect. Now, this is the average hospital in the county I have selected. Perhaps your hospital or your region has somehow different characteristics, and we allow the user here to actually personalize the hospital, perhaps the nurse or the staffing manager, and make it close to what they have observed over the last past weeks. Let's say in a specific hospital, perhaps the average admissions in the ICU were quite higher than the average. And by applying please focus in this plot that deals with the ICU admissions and occupancy. We see that indeed the numbers to be expected are much higher, and we do see a downward trend towards the end, and that's already informed, that's because it's informed as well by the actual COVID historical data and projections. Now, and you can reset the defaults. If now you want to run what-if scenarios about the future, for example, let's say, I hope it doesn't happen, there is another big wave of COVID cases, 8,000 per week, perhaps, new cases. and perhaps the disease is more severe, so we have longer lengths of stay in the ICU. Again, please focus here. And we can see that indeed the projection change, and we anticipate the increased volume of patients in the ICU. This app, with some modifications, of course, using the hospital data, is currently in use in one of the biggest hospital systems in the US. I want also to point out that for those interested to find out more, please visit the alias, as you see it here, and also visit the documentation where you will find a lot of detail about how you should use the app and also the algorithms that are running behind it. The second app, the second solution I want to talk about, so this was a provider population health. I want to talk a little bit about provider/pharma solution, Gene Mutation AI. And this is in the suite of precision medicine applications that we are developing. So the application can consume whole genome or gene panel next generation sequencing data. It evaluates a patient's risk for a disease that we are interested in. I'm going to be giving an example of triple-negative breast cancer. It can seamlessly integrate different AI models in the analysis pipeline, for example, for different models for different types, subtypes of cancer, identifies genes that influence patient risk and are potential drug targets, which can be very, very interesting, and monitor model performance over consecutive cohorts to ensure that the app is working as expected. You can find this app in our App Store. I'm going to go straight here. We have a tab where we allow the user to quickly inspect the data, but also upload new data, either from a local. We also have a Snowflake integration, so we can connect directly to your Snowflake account and pull data that you already have put there. You also see here, these data tend to be very wide, especially if we're talking about whole genome sequencing data. With this toggle, you see a pre-processing pipeline, in this case for dimensionality reduction. For this specific example, we are actually implementing knowledge about how genes are grouped in pathways, and we have summarized the binary mutation data into pathways. Once we have imported the data, we can go straight to the predictions. We have the selected data set, and we can select a patient we want to explore more, and an experiment. And here is what I was mentioning, that you have a drop-down of all the models already trained, and which can also be enriched. This library of models can be enriched by this upload button here that directly incorporates a new module, for example, of a different cancer subtype that perhaps we want to examine. As I press the button show predictions, the predictions happen in real time. You see the dashboard being populated. And what we first see is the binary classification of for this patient. This patient actually is expected to have high-grade breast cancer, and we see here more specifically their estimated risk, which is a 42.3%. What is very interesting, we can leverage the capabilities of MLI, explainability, that our platform offers, and start digging deeper into what causes, what drives this high risk for this patient. To do that, we're going to look into Shapley values at the local level. Global is for the entire, refers to the entire cohort. And we see that the very well-known PI3K pathway actually is primarily, but not exclusively, driving this high risk for this patient. But it's not only that. We are also offering assurances about the performance of the model over different cohorts, and how confident can we be about this prediction? In this case, by comparing the prediction of this patient to the cohort, and indeed we see it's one of the highest risks we observe. And also we offer an orthogonal method to understand how this patient compares with other patients in the cohort by finding the 20 more similar patients on the basis of their features. In this case, it's surprising because this patient actually looks more similar to low-grade patients than to high-grade. And we can understand with this radar plot why this might be the case, because the low-grade patients have low mutation frequencies in all these pathways. We see, however, the specific patient differentiates in the pathway of immune signaling and has higher mutation frequency there. We can move forward and actually run a what-if analysis using the PDP and ICE plots, that are again capabilities offered by our platform. And we can explore better in the context of the specific genetic background of the patient, what will happen if with some magical reason, with some magical way, we had a change in the mutation frequency for this specific pathway. I'm going to deactivate PDP. This refers to the population. And we see with the ICE plot that indeed an increased frequency, given exactly the same genetic background for this patient, the gene mutation frequency, increasing mutation frequency of the genes associated with immune signaling does confer an increased risk for this patient. And perhaps there is something more there to explore for this specific patient to understand the reasons for this predisposition. As well as if we are in the target discovery phase, perhaps we can use this information to further dig deeper and understand better the causes of this disease. Finally, I want to close with a disparate impact analysis. There has been a lot of talk about the availability of genetic data from diverse populations. This continues to be a problem, and we want to ensure that the model keeps performing as we expect, as the data scientists who were training the model expect, despite, for example, the ethnic background of the patient. And we offer here the disparate impact analysis that does exactly that. And with that, that's all I had to share. Please watch this space, H2O Health, and thank you very much.
Thank you, Nikki, for the wonderful presentation. Saying just again, go out to H2O.ai/health, or you can go from the main website as well. Check out all the work we're doing and figure out if we can help you in some way of the shop. I mentioned it was the last, but I kind of lied because we still have, I'm going to hold Thomas back to his feet. So since we had some technical difficulties earlier on the Feature Store demo, I'm going to let him back and then show the actual full demo so that you guys can see what's in that Feature Store.
Thanks a lot, Vinod. Thanks again, everybody, for the opportunity to present in front of you today. I'll just reset us again on the demo with Feature Store. What I was attempting to show at the beginning was training a model with features from H2O Feature Store in Driverless AI. Just to provide that context, we're predicting flight delays due to weather disruptions, and we had a set of superheroes who are our personas. T'Challa from Black Panther, who's a data engineer, Aurora, aka Storm from the X-Men, who's a data scientist, Peter Quill, also known as Star-Lord from Guardians of the Galaxy, and Scott Lang from Ant-Man, who's a data scientist. So we went through and we showed connected to Feature Store and registering and ingesting a feature set, which is what T'Challa did. But if we run all the way back to where we were when we left off, we had just done the join between the two feature sets, which T'Challa did as the data engineer, and we were getting ready to ingest it into Driverless AI, which we did with Aurora. So Aurora is going to use those features to set up, build a model in Driverless AI. So we did the connection already. While I was off the screen, I went and completed the ingestion for the data from Feature Store into Driverless. And we went through and we can just kind of review real quick what the data is in here, and just so you can see the data frame. So here's all the output for the columns. And I already have all the experiment variables set up for Driverless. So what I'm going to do is I'm going to go ahead and launch this experiment. While we're running the experiment, it's going to kick off in Driverless. Oops, let me run it again here. Right, so it kicks off in Driverless. And I'll actually do the split here real quick. And do the prediction. In this case, we're looking for the time delayed. If we're here while this experiment's running, I can go back through and just talk about some of the setup inside of Feature Store. So today, right now, I'm running a lot of these helper functions out of the notebook, but with the latest release of Driverless and with H2O Feature Store coming into the AI Cloud, all these functions will go away because you can run it directly from Driverless or inside the Feature Store UI. But when we connected to Driverless, I was able to set up all the variables for the Driverless experiment. So here I'm selecting is the flight arrival delayed, and it's just a simple classification experiment. So while it's running, we'll see how long it takes if I have enough time. But when it runs, what happens is we'll get the mojo that's produced from it, and we'll extract it here, and we'll be able to re-ingest directly into the Feature Store. But you can do this all straight from the notebook, and you can also view the features inside of H2O Feature Store UI. So with that, I think the experiment is probably going to run a little bit longer than we want to, but just to show you that you can use the data from Feature Store not only to do feature transformation from raw data, we can also take those features that are from the Mojo and put them back into H2O Feature Store. And with that, I'll stop there so we can wrap up. Back over to you, Vinod. Thanks.
So you saw we covered a whole slew of stuff. I mean, and so folks who stood through the whole thing, thank you for your patience. I really appreciate you guys staying over the entire presentation. There's a lot of products. They all are available in the AI Cloud. The best way to get started is go to H2O.ai/free trial and sign up for the AI Cloud account. It's all in there, and you should be able to play with it. Give us feedback as you try these different things. We have different places for us to connect with us. You have the H2O Slack, or you can just email us directly, and we'll be able to get feedback. I just want to point out one quick thing. As you are looking through all these different products, quick way to know about what all the things out there are is a documentation page. So if you go to docs.h2o.ai, that's your starting point. All the different products we talked about, they're all here, and newer stuff as it comes in will all be here. So if you're able to go through, pick up the documentation for any of these products, see what's new, see what's coming up, and then if you want to try it, go to H2O.ai/free trial. So go try for free, sign up for a web form, and you'll be able to get into our H2O AI Cloud, and then all the products that we talked about will be available for you to try out there. So with that, we come to an end for the first H2O AI Product Day. So this is the first iteration for us. We learned a lot doing this. We'd love to do more of these in every quarter, when we hope to see you soon in person at one of our meetups or in the next Product Day, which hopefully will be live. Thank you all for staying on, and wish you all a great rest of the week. Goodbye.